Hi, my name is Maximilian Schwarzmuller, and in this course, I will teach you all about React, the most popular JavaScript library you can learn these days. Now, in this course, we're going to build a complete example project, and you're going to learn all about the important key features you need to know about React step by step. And therefore, let's dive right in, and let's dive into the most important question first. What exactly is React? So let's dive right into this video and this topic by answering the most important question first. What exactly is ReactJS and why would we use it? Why do we need it? What's the problem it helps us solve? Regarding the what, we can of course visit reactjs.org, the official webpage of ReactJS. And there we learn that React is a JavaScript library, and it's a JavaScript library for building user interfaces. Now that's quite straightforward. It's a library for the JavaScript programming language that helps us build user interfaces. But what exactly does this nice sentence mean? ReactJS is a library, and to be precise, it's a client-side library. It's about client-side JavaScript. So the JavaScript code which runs in the browsers of your visitors. And that is important because we use JavaScript in the browser to manipulate web pages after they were loaded. And that allows us to build rich, highly interactive, modern user interfaces for our websites. Take something like Netflix, for example, which is actually built with React. There we can browse around, we can hover over one of the movies or series, and we get more details there. We can add it to our list, and we can go to that list page, and everything here happens very smoothly and also quickly. We never need to click anywhere and load a new HTML page. That refresh icon in the top left corner never spins. Because we never request a new HTML page, we never have to wait for a new HTML page to be generated by the server. And that happens because JavaScript is doing some work here, and it's updating what we see on the screen, the DOM, whilst we are working on that page. And that gives us that nice user experience, that nice UI, which we know from mobile apps, for example. When we work with a mobile app, we're used to things being very reactive. There we can work with the app and switch between different screens without having that latency, which we know from some websites, without requesting new HTML pages behind the scenes. So mobile apps therefore feel very reactive. Things happen instantly. We don't need to wait for new pages to load or for actions to start. And traditionally, in web apps, that was different. There we often had to click a button and then wait for a new page to be loaded and to show up. And whilst that, of course, also does work, it is not the same user experience our users know from their mobile apps, and it's often not the user experience we want to deliver, therefore. Now, that's a problem we can solve with JavaScript in the browser, because that allows us to manipulate the DOM and therefore what the user sees without requesting a new HTML page and waiting for it. And therefore, just JavaScript would be enough. But let me give you an example of just JavaScript and why we might want to use something like React instead of just JavaScript. This is a very simple demo here. I have some content on the page, and when I click delete, I get this overlay where I can confirm or cancel. Now, both buttons don't do anything but close that overlay, as does clicking that backdrop, but what you see on this page here, or what happens when we click delete, all of that is controlled with JavaScript. I got a HTML file with some very basic HTML content, some styling, which we can ignore, and then the magic happens in this app.js file. In there, I got some code that in the end adds a listener to this main button which we got on the screen. so to this delete button here. And when that button is clicked, I fire this show modal handler function, and in there we run a bunch of JavaScript code to create various elements, divs, paragraphs, and then the cancel and confirm buttons to configure those elements and add text or CSS classes, and to add event listeners to those elements as well, to then fire that close modal handler function, which in the end removes the overlay, this modal as we call it. And then still in the show modal handler function, I got some code that combines all those created elements and brings them onto the screen. This is the JavaScript code responsible for opening this overlay here. Now it works and it's not too bad, but it's quite some code for this simple action. And here we only got one to-do in this demo application. If we would add multiple to-dos, if we would repeat this HTML code multiple times to render more to-dos on the page, or to even render those to-dos dynamically after fetching them from a database, for example, this code would become far more difficult, far more complex. For example, I couldn't just select a button on the page with that query selector, because we would have multiple delete buttons for multiple to-dos, and we would have to make sure that for different to-dos, different overlays are opened, and when we confirm the deletion, the correct to-do is deleted. We're not even doing that here in this demo, but that would be more complexity which we have to add and handle if we build a more realistic app here, a more realistic website. And therefore, just JavaScript works and can sometimes be a good choice, but it can also reach its limits. And one of the reasons is that with just JavaScript, you have to write every single step that should be taken. We want to create an element. We want to set its content. We want to add classes. We want to add a click listener. Then what should happen on that click listener? Every single step needs to be described. This way of programming and bringing something onto the screen is called an imperative approach. We simply describe action after action, step after step. And that can reach its limits. And in addition, even if we don't reach any limits, we as a developer have to take care about all the nitty-gritty details. We have to run the low-level code for creating a button, for setting its text content. And therefore, in the end, we reinvent the wheel over and over again, doing repetitive tasks. Now here's the same example with React. This works in exactly the same way, but the code looks very different. I got a React project here. And as a side note, you find both code repositories, both code snapshots attached. And here in ReactJS, this might look a bit more complex. We got more files involved here, but that's something we're going to learn throughout the course, why we have multiple files. But in the end, this is the main code that's responsible for bringing this to-do onto the screen. And what's very interesting here is that we have like a custom HTML component here, a custom HTML element. And indeed, React is all about those components. React is all about splitting your application into small building blocks, small components, where every building block, every component has a clear task, and therefore your code stays maintainable and manageable, and React, the library, will do the heavy lifting of rendering something on the screen and of combining all your code. So for example, if we look into the code for this custom element which we built here, which lives in this to-do.js file, then we here again see that I have some HTML code for rendering a to-do, but that we have some kind of placeholder in here, and then some kind of other code which we don't fully understand yet, but which we will understand and learn about throughout this course. And in the end, that's the code responsible for rendering such a to-do, and for rendering the modal, this overlay here, as well, and for rendering it conditionally. And what's interesting here is that even though we don't understand this code yet, and even though it's certainly strange that we have HTML code in JavaScript files, even though that's all weird, we can definitely see that we don't have a bunch of step-by-step instructions here. Instead, we kind of define what we want to have as an end result, and then we have some placeholders, some flexible elements there. And then we have very simple instructions here, which in the end then will be processed by React to change what's visible on the screen. And all these low-level instructions for creating elements and setting text content and so on, those instructions are not written by us when using React. Instead, they will be written or defined, if you want to call it like this, by the React library. We as a React developer work on a higher level, which makes working with React and which makes building complex user interfaces way easier. And that is why we want to use ReactJS. It makes building modern, rich, complex user interfaces easier, and it does so by giving us a higher level syntax where we write code in a declarative way, in a declarative component-focused way. We define what we want to have on the screen, what the end goal is. We create these custom HTML elements, and React will do the rest. And one side effect, for example, is that if we wanted more than one to do, we could just copy that custom element, change maybe that text, that configuration, and boom, we got a second to do here. And we got a button on that to do which works as well. And that is why we use technologies or frameworks like React. Now, because things get easier with React and because we can build those rich user interfaces with React and JavaScript, when working with React, we often build so-called single-page applications. Because whilst we can use React to control parts of a HTML page, let's say some interactive sidebar, and therefore we add a widget, you could say, to a page where only a part of the page is controlled with React, it is more common to control the entire page with React, which means that we use React for everything we see on the screen and even for switching pages. So when we click on a link and we load a new page, as I did with Netflix when I clicked on my list, it looks to the user as if we switched the page, but we actually don't request a new HTML file from some server. Instead, we just used JavaScript through ReactJS to change what's visible on the screen. And that often leads to a smoother UI and a better user experience, as you see it at the example of Netflix. It's built with React, and there we never request a second HTML page. Hence, it's a single-page application where, after the initial request to the site, React takes over and controls what we see on the screen. Now, throughout this course, we are going to learn React in depth, and we're going to start with this basic dummy demo here to learn about some core concepts. And then later throughout the course, we're going to build this meetup project, this mini project here, where we see more React features in action and where we can practice all those basics and where we then at the end really understand how React works and which features it brings. Now, this course is about React, but it is worth noting that there are alternatives to React.js. Now, we're going to focus on React here, and React is one of the most popular front-end frameworks or libraries, however you want to call it, you can learn. It's a lean and focused component-based UI library. It really focuses on this component thing, and it doesn't have a lot of other features built in. If you need other features like routing, which we are going to learn about in this video, then you need to bring extra third-party packages. That's not horrible, but it is something to be aware of. React itself is really just focused on bringing stuff onto the screen and updating that for you and allowing you to build these custom HTML elements, these components. That's the core focus of React. Now, an alternative to React, which has more built-in features, would be Angular, another very important and very popular front-end framework. And I got a course on this as well. Angular is a complete component-based UI framework, so it also focuses on components, just like React, but it ships more built-in features than React. It also embraces TypeScript right from the start. And it can be overkill for smaller projects, therefore, since it has way more features built in. But for large projects, on the other hand, you don't need to rely on the community as much, because there's more built into that framework. So that's simply a little consideration you have to make. The syntax also looks a bit differently, because whilst it is component focused, building these components works a bit differently with Angular than it does with React. Again, I got a course on that if you want to check out Angular as well. And we also have another very popular framework, another popular alternative, and that would be Vue.js. Vue.js is kind of like the mixture of Angular and React, in between those two extremes, if you want to call it like this. It's also a complete component-based UI framework, and it also includes a lot of features, but a bit less features than Angular, but more than React. It includes core features like routing, for example, and therefore with Vue, you also have to rely less on the community, and still you don't have as much overload, possibly, as you might have with Angular, depending on what you build. I also got a more detailed comparison video on these three technologies in case you're interested in that. Now, all three are super popular. React currently is probably the most popular, but all three are great. I got courses on all three, and therefore checking those out might be a good idea as well. But this course, of course, is about React, and therefore let's not lose any time. Let's dive right in. So let's get started with React, and let's dive into that React code and learn how to work with React and how to write React code. Now, in the project I showed you before, you might have noticed that I had a couple of files here in this React project, and these files are actually JavaScript files, but in those files, I then use HTML code. And that is not something you can normally do. Normally, you can't add HTML in JavaScript, at least not like this. You can add it as part of a string or of a template literal, but not just like that. That's not syntax that would work out of the box. That's not syntax that would work out of the box. And indeed, it wouldn't work just like this. That's why for working with React, we set up a project that's a little bit more complex than a vanilla JavaScript project. In the standard JavaScript project, I just have a HTML, CSS, and JavaScript file, and in the HTML file, I simply import those external files, and then they do their thing, because that is all just standard modern JavaScript. With React, to write React code in a convenient way, we can't just set up a project like this, because we want to use this HTML in JavaScript syntax, and the browser would not understand this syntax out of the box. That's why a React project is a bit more complex and involves more files, because it involves a so-called build step, which means the code we write will not be the code that ends up in the browser. We simply write code in a very convenient way for us as a developer, and then behind the scenes, that code will be transformed before it reaches the browser. And in addition to that build step, with a modern React project, we typically also want a development server which hosts our running React application locally on our machine, and which, for example, updates the page in the browser whenever we make changes to our code, so that we don't have to reload that page manually all the time. And because that's the kind of setup we need, we don't just create a couple of HTML and JavaScript files. Instead, we typically create a React project with an extra tool that gives us all that behind-the-scenes magic added to the project automatically. And the most popular tool for that would be Create React App. You can simply Google for create-react-app, and you either find this entry on the official docs or this GitHub repository. In the end, you can use either of the two. There you learn a bit more about it and that you might not need it, but in reality, for most React projects you do. And then you learn how you can set up a project with that tool. And it's in the end just one easy command. Now, for this command to be executable on your system, though, you need to install Node.js first. Now, Node.js is a JavaScript runtime that allows you to run JavaScript outside of the browser. We don't write any Node.js code with React. React is not a Node.js library or framework. It is about browser-side JavaScript instead. But we do need Node.js to install this Create React App tool or to use this Create React App tool. And the project generated by that tool will also use Node.js behind the scenes for this automatically reloading development server and for some code transformations which transform the code we write into code that runs in the browser. That's why you should visit nodejs.org and there install the latest Node.js version, whatever that version is when you're visiting this. Simply install the latest version here by clicking on it. That will then give you an installer for your operating system. It's available for macOS, Linux, and Windows, and it should automatically select your operating system here. And then you simply walk through that installer and install Node.js. Here I'm on macOS, but the process will in the end be the same on Windows. You can just accept all the defaults, don't need to change anything there, and that will then install Node.js on your system. Now, once that is done, you are ready to run this npx create react app my app command. And for this, simply open up your default terminal or command prompt on Windows, and in there use the cd command to navigate into a folder where you want to create your React project, your development folder, your desktop, anything like that. Then, once you're in that folder, once you navigated there inside of that terminal or command prompt, run npx create-react-app, and then simply something like my first app, or in my case, React-course. Simply hit enter thereafter, and this will now create a new folder named React course in that folder in which you ran that command. And here I need to confirm that I want to temporarily install this Create React App tool. And then this folder will be created of that name you chose here. And in that folder, a brand new React project will be set up for you. Now, React project sounds like a big thing. It will still be a simple web page with JavaScript managed through React in the end. But because of these transformations I discussed, because of that, it will be a project where all these transformation steps are already pre-configured for you, so that you can focus on the code and not on the setup of the project. Now, this can take a short while, and if you're facing any problems here, make sure you got no firewall blocking outgoing traffic or anything like that. No antivirus tool that could be interfering here. And then at some point, you should be done. You should see output that looks something like this. Now, with that, we can cd into that newly created folder and then run npm start, which is a command based on the Node Package Manager, which is a tool that was installed together with Node.js, which will in the end execute a script that was pre-configured in that created React project. And when we run this script, a development server will be started, as it says here, which will host this React project. It should open a new tab in your browser automatically on localhost 3000 and display a starting project there, a starting website. If it didn't, simply manually go to localhost 3000 or whichever address is shown to you here. And then you should see something like this. The exact starting project can change over time, since the starting project template can be changed by the Create React App team, but ultimately you should see something like this. And that's now a little dummy website which was pre-built for us and which already exists in that starting project. Now we are going to get rid of that starting project here and build our own website though, our own React project. Now I did now open this React course folder, which we created in the last step, with my editor, Visual Studio Code. Now you can use any code editor you want. If you have a favorite editor already, you can stick to this. But you should use some code editor to have a better time working with React. And here I'm using Visual Studio Code, which is a great free IDE for web development. It's available for all major platforms, macOS, Windows, Linux. You can simply download it from code.visualstudio.com. And then once you download it and installed it, simply open your folder that we created in the last step, this React course folder in my case, with Visual Studio Code. Simply with File Open or Open Folder on Windows. Now once you did that, you should see something like this. Now you can tweak the settings of Visual Studio Code if you want to. If you have a different theme and you want my theme, you can go to Preferences, Color Theme. I'm using the Dark Plus theme. And it is worth noting that with Visual Studio Code, under View, you can tweak the appearance of the editor. For example, if you have a status bar at the bottom and things like that, which I disabled here. And you can go to View Extensions to install extra third-party extensions into Visual Studio Code, which can add new functionality. Now I got a bunch of extensions installed, which you don't need, but there's one extension which I do recommend, and that's the Prettier extension. You can simply search for Prettier here, and then install that extra extension. This is an extension that helps with code formatting, and which therefore helps with making your code more readable with a simple keystroke. For this, you then also want to make sure that under Preferences, Keyboard Shortcuts, if you search for Format Document, you have this shortcut bound. Because that Format Document shortcut can then use Prettier to format your code and make it more readable. For this, to ensure that you use Prettier, you might want to go to your settings, to your user or project-specific settings, and then there simply search for Format, and under Default Formatter, you want to select Prettier VS Code, which should be available since we installed Prettier. Now that's the setup I'm using here in the end, and with that I got an editor configured for my requirements, which we can now use to dive into that React project that was created for us and which we can now use to write some React code. So let's now as a first step clean up this project to get rid of some of the starting files and then start from scratch again to learn React in depth. Now this project which was created for us has a couple of starting files which we don't need here. For example, a file for automated tests. That is something which I cover in my complete guide course, but we don't need it here. So I'll get rid of that file and also of the logo SVG, report web vitals, setup tests, and app CSS. If you got more files, you can get rid of those as well. You should be left with an index.js, a app.js, and an index CSS file thereafter. Now in index.js, I will get rid of that import of report web vitals, and I'll explain these imports in greater detail in a second. For the moment, let's just focus on cleaning up. And I'll get rid of that code down there, and I'll get rid of that strict mode, because for the moment, for getting started, it is simpler if we just get started like this. In index CSS, I'll get rid of all that code as well. We're going to add different CSS code soon. And in app.js, there I'll get rid of these two imports at the top, and then of all the content here in this return statement, all this HTML code. For the moment, we can just add a simple div here where we say hello. Now we can save that, and that's now the starting setup with which I want to get started. You also find this starting project snapshot attached to this video so that you can also download it from there and get started with that. If you do download my attached snapshot though, there's one important step you must not miss and you have to go through. You have to install third-party dependencies of that project. Because since it is a bit of a more complex project setup, working with third-party packages like the React project works a little bit differently here. We got this package.json file which lists all the dependencies of this project. And there we, for example, see the React library and another package which is part of the React library, which are listed as dependencies. Now, these dependencies are managed and installed automatically for us, and a big code bundle with our code and that third-party library code will be generated automatically behind the scenes by those build steps which exist in this project as well. Those are brought in by that React scripts package. Now, I am aware that this sounds fairly overwhelming and complex right now, especially if you never worked with anything like React before, and you're used to standard setups where you have a HTML file and a bunch of JavaScript imports, but we can ignore all of that for the moment. We just add dependencies here, and we can then import them into our JavaScript files. That's what you see here with those strange import statements. And then this build step, which is part of this project setup, which is started when we run one of these scripts like npm start, which we did before. These scripts will then in the end combine and transform all the code and combine the third-party package code with our code and make sure that the result is an output which the browser understands. Now, because we have that setup, if you download my attachment, you need to run one extra command before everything here will work for you. And for this, it's best if you open the terminal or command prompt, which is integrated into Visual Studio Code, with terminal, new terminal, which is your standard operating system terminal or command prompt, just already integrated into this IDE. And any commands we run here are then automatically executed in this project folder. And here you need to run the npm install command, which will simply download all those dependencies this project has and store them in this node modules folder, which we have here. That's a folder in which we will never work because that holds all these third-party dependencies and their dependencies which our project needs. So that's a folder which is here, but which was not part of the attached code because it's a fairly large folder and hence the attachment would be unnecessarily big, and you can simply recreate it by running npm install in that folder that has this package.json file. So that's why we need to do that then. And thereafter, you can run npm start again to bring up that development server. And I will do that here again. And for this, I'll go to that other terminal where I ran npm start before, and I'll quit this process with Ctrl+C now. Now, as long as you don't quit that process, the development server is up and running and listening to code changes to then display them in the browser. You can quit this server whenever you're done with development for the day, and then you simply restart it with npm start again if you want to pick up development again. But now I'm not restarting it in this standalone terminal, but instead in this integrated terminal, which is already navigated into my project folder. And the advantage of starting it here is that I will always immediately see any errors that might occur if I have an error in my code, for example. And that's why I'll start it here, zoom out a bit, make this a bit smaller, and keep that up and running as long as I'm developing. So don't close the terminal, don't run Ctrl+C here, keep it up and running. And if you do that, and you go back to localhost 3000 and reload, you should just see hello there because of our cleanup process. Now, that was a lot of work just to get started, but I am a big fan of having a clean start and explaining what's going on here instead of just throwing code at you and leaving it up to you to figure out what's happening. That's the project setup we're dealing with, that's my IDE, and that's the cleaned up project, which you'll also find attached. And therefore now, let's start writing our own code and let's understand these different React features and this strange syntax here step by step. Now, with the project cleaned up, let's explore React and let's write our own React code. Currently, we got two JavaScript files here, index.js and app.js. The index.js file will be the starting point of our React application. The code written in here will be the first code that will be executed in the browser when we load our project in the browser. So what we see here in the browser is the result of this code line here executing in the end. Now, we don't fully understand this code line yet, but what we do in this file is we're importing a couple of things. That is how in modern JavaScript, supported by that build setup we have here, supported by that npm start script and what it does behind the scenes, how we combine multiple files and how we import features like objects or functions from file A into file B. And here we're, for example, importing the React DOM object from the React DOM library. So that's not an object we created. That is an object created by the React team, exposed in that React DOM library, which is part of our project because it's part of our dependencies here. Now, on that object, we call a render method. And to that render method, we pass this strange HTML code. Now, this HTML in JavaScript syntax here only works because of that build step, as mentioned before, and it's actually called JSX. This kind of code is called JSX code, this HTML in JavaScript code. JSX is a special syntax which is not understood by the browser, and which therefore is converted behind the scenes, but which is more convenient for us as a developer to write, because working with React will be about building custom HTML elements, these components, and combining them together. And that is way easier if we can just write HTML code, kind of, in our JavaScript files to describe the desired output. So here we kind of create or we use our own HTML element, the app element, which is actually imported from that app file. The file extension is missing here because for JavaScript files it can be omitted. And the second argument to the render method in the end just tells React where this element should be rendered in the real DOM. Now here we're selecting an element by ID with an ID root, and we can find this on the single page that is part of this project. We find it in the public folder. There we got a couple of images, but also one HTML file. That is the single HTML file that makes up this React application. Because I mentioned before, you typically build these single-page applications with React where only one HTML file is fetched from a server, and then React takes over and controls the DOM and what's visible on the screen. Now in this index.html file, in the body section, we got a div with an ID root, and that ID root should look familiar. That is the div which we in the end select with this document get element by ID code snippet here. And therefore, in the end, what we tell React with that line is that we want to render our app HTML element, our custom HTML element, which is defined in this app.js file, into this place, into the place of this element with this root ID. So into the place of that div here in the end. That's what we're telling React. That's why if we visit our page and we inspect it, so we don't view the page source, but we inspect it with the dev tools here, when we have a look at the rendered DOM here, we see embodied that there is this div with an ID of a root, and in there we see our div with hello, which is the content we defined in app.js. And that should make sense because it is the app thing, which we import from the app.js file, which we render here. Now let's take a closer look at this app thing then. That is a function which we export to make it available outside of this file, but in the end, just a standard function, a standard JavaScript function. The only special thing about that function is that it returns such JSX code. so this HTML in JavaScript code. That's the only special thing. Other than that, it's a regular JavaScript function. And that is super important. What we have here is a so-called React component. We can use it like an HTML element, as we're doing it here in index.js, but it's of course not an HTML element the browser would know, but one defined by us, the developers of this project. Now this component, as it's called in React's world, this custom HTML element, is in the end just a function. A function which is defined and exported, and specifically a function that returns JSX. That's important. A component, so a function that should act as a component and be usable as a component by React, must return something that can be rendered in the browser. That could be plain text, it could be a couple of other things, but it can, and most typically will be, HTML code as well, so this JSX code. And what's interesting is that in the browser, if we have a look at the DOM again, we don't see our app element anywhere here. We don't see an HTML tag called app. Instead, we just see the content of our component here, this div with hello as a text. Because these custom elements, these are not known by the browser. We just write this code in our React application, and then when it runs in the browser, React will not render these custom elements, which wouldn't tell the browser anything, but instead it will render the content returned by these custom elements. And that's how these React components work in a nutshell. That is already one very important first piece of knowledge here. That we have these React components, which are functions returning JSX, which we can use to, well, tell React, and therefore in the end the browser, what should appear on the screen. But of course we typically don't do that with just one simple component that just returns a div of hello. Instead, I mentioned before that I want to rebuild this basic first example with this delete button, and then thereafter dive into a little bit of a more complex project in a second step. And therefore, let's now work towards that first example with that delete button and that modal overlay. Now for this first example, for this delete button, let's remove this hello text, and instead inside of this div, I'll add another div. I'll add another div, and before that div, a h1 tag where I say my to-dos, because that was also some text which we had there. And then this other div next to the h1 tag inside of the outer div, that div will contain that single to-do, item which we have in this dummy project. For that, I'll use a h2 tag for the title. And then below that, I want to have that delete button here. Now, I'm using regular HTML elements here, because when working with JSX, you can use your own elements, your own components if you have some, but you can also use all the built-in default browser tags, like divs, paragraphs, h1 tags, buttons, inputs, and so on. So in the end here, in the component, we just write the HTML code that should eventually appear on the screen. So the output that should be rendered by the browser. So for this, we have our to-do item here and some title above it. And on that button, I'll now say delete. That was the text we had here. Now for styling purposes, we're going to add some styling soon. I'll add another div here and actually put that button inside of that div. And now I pressed this format document shortcut to auto-format this code and make it a bit more readable. Now that's a more complex HTML structure, and if we now save this file and we reload, or actually we don't even need to reload because of this auto-reloading built into the dev server, we should see that output here. The title, the delete button, and my to-dos. Now, the delete button is not doing anything at the moment, and the title also is just static text, but we again see that we can influence what shows up in the browser with the code we define in our app component here. Now, some styling would be nice, And for this, I attached the index CSS file, which you also find attached here, which contains some basic styling for this first demo. You can simply replace your index CSS file with the attached one. And if you do that and reload, it looks a bit nicer. And we can also now add some CSS classes here to this code. Some CSS classes that will also influence the styling. For example, to this div, which contains the title and the nested div, I want to add a class of card. Now, in regular HTML, you would do that by adding the class attribute and setting this to card, for example. Now, this is not how you should do it with React. This code here looks like HTML, but it actually isn't. Behind the scenes, it is transformed to standard JavaScript. And in standard JavaScript, for one, class is a keyword, but even more important than that, if you look at vanilla JavaScript, the property name of a HTML element object for assigning or for setting the CSS classes on that object is actually class name, not class. That's just how vanilla JavaScript works. And therefore here, the attribute name actually also is class name. Now again, this can be confusing because it looks like HTML, and in standard HTML that would be class. But since this isn't HTML, since this in the end is JavaScript, just looking differently, we need to keep minor things like this in mind. Now, the good news is, however, that this is one of the very rare cases where the attribute name differs from the property name, and we have to use the property name here, and hence we don't use what we would write in standard HTML. In most cases, you can write standard HTML code here, and the class name is the most prominent special case in React, where you assign a CSS class to an element with class name as a attribute, in quotes, added to an element. But with that, if we save this again, now we have this card look of this to-do. Now, there are a couple of other classes that should be added. For example, on this div, which holds the button, you should add a class name of actions. And on the button here, we add a class name of btn for button. We do all of that. That's the look we get, and that looks a bit nicer. So now we also added some styling to our first component simply by changing the code in the index CSS file and adding a couple of classes here, and therefore our first component is taking shape. However, at the moment, all that code is in one component, and there are a couple of reasons why we might want to split that up and also make our component a bit more flexible. This first code here for our to-do element exists in this app component. There's nothing wrong with it, but not only do we have some static text here, we would of course want the actual to-do title here. Not only is that the case, if we would want to add a second to-do, we would have to replicate this entire code block. And if we then ever want to change anything about that, let's say we want to add an extra span to that button, whatever, then we have to do this in all those places where we use the same code. That's not really what we want to do. That's why React embraces this concept of components, of building our own building blocks, which we then compose together. For this, I'll remove this duplicate code and instead create a new file. A new file in that src folder, which I'll name to-do.js. The name is up to you. The extension should be .js though, and that will simply hold another component. We're going to build our second component here. Now, typically those component files, except for that so-called root component, this app component, are stored in a separate components folder, which I also added in the source folder. So I'll move to-do.js into that folder. That's not a must-do, but it is a convention to keep your project organized. Now in this to-do.js file, I want to create my second component, that to-do component. And we did learn that a component in React is just a function. So in the end here, we define a function, to-do, and then we export that. We need to export it like this with this syntax to make this function available outside of this file and usable in other files. Now, one important note about this function name though, you can name your component functions however you want, but there is one important restriction, one important thing to keep in mind. The name of the function should start with a capital character. That matters because when we later use this function as a component in our HTML code, so if we use it as a custom HTML element, then it will have to start with a capital character there as well to differentiate it from the built-in HTML elements. React wants custom components to start with a capital character. So now we have our function here. And then here in this function, we must return something that can be rendered to turn this function into a component. And that something is this div here. This div with the class name card. I'll cut it from app.js and then return it here in to-do.js and press that auto format shortcut again. So now that's our to-do function returning this JSX code. Back in app.js, we can now use this to-do component. And we don't do that by executing to-do like a function, as we would normally do that, but instead we use it as a custom HTML element, just as we did it with app in the index.js file. So here, where I cut the code from, I'll add to-do like this, as a HTML element. The only special thing here is that it's self-closing. Alternatively, we write an opening and closing tag. This would work as well. But since there will be no content between the tags, we can also write a self-closing tag. But then it has to have this /. It would not be allowed like this. Now, as noted before, it is worth pointing out here that this component, this custom element, when we're using it here in this JSX code, that there it has to start with a capital character. So to-do with a lowercase t at the beginning would not be valid, because React internally differentiates between built-in HTML elements like divs and h1 tags and custom elements by casing. All these built-in elements start with a lowercase character. Custom elements built by you or others have to start with an uppercase character. And that is just something to be aware of. Now, to use to-do in app.js, though, we need to import it from the to-do.js file. And for this, at the top of this file, we import to-do from /components to construct a relative path to that components folder /to-do. Again, the file extension of .js can be omitted here. That's now this to-do imported and rendered here. If we now save all files, we see the same output as before, which is good. That means that everything still works, but we're now getting to that output with help of our separate component. Now, if we want to have multiple to-dos, we just got to replicate this to-do component here in the app component, and we now have a couple of to-dos. And if we now ever want to change anything about that to-do component, about this HTML markup that makes up a to-do, we just need to do it in the to-do.js file, like adding this span, which has no real purpose but acts as a demo. And if we then save that file, we see that extra span in all our to-dos, because we define it once and then reuse it multiple times. Just as in vanilla JavaScript, we would define a function once and then possibly call it multiple times from different places in our application. It's the same concept here with React components. Though we don't need the span here, so I will get rid of that now. What we do need here, though, is some configurability. At the moment, all to-dos just say title. And that's not too useful. These should be different to-do titles for our different to-dos. And of course, I can change the title here to Learn React, But since I do this in this to-do.js file, this will now affect all to-do usages again. So all to-dos which we're outputting. So that's not how we make this more configurable. Instead, we want to let the place where we use the to-do, so the app component, pass different data into these to-do components, just as we pass arguments into functions when we call them, to then output different data in each to-do instance depending on which data we're passing in. And that's what we're going to do now. To make our component a bit more configurable and accept different data, we in the end want to utilize a concept which we know from the function world and from standard HTML elements. In the place where we used to do, so in this app component, it would be nice if we could add an attribute like text or title, totally up to you. Let's go with text, and then set this to some value, like learn React on the first to-do, then master React on the second to-do, and let's say explore the full React course in the third to-do. Now it would be nice if we could do that, but if I add this here in app.js and save it, this has no effect on what we see on the screen. The reason for this is that we're setting these custom attributes, but in the to-do.js file, we have no code that would pick up those values. Nonetheless, this is how you do pass data into a component. We just also need to write some code in the component to then accept and use those received values. And we do that with a concept called props. We accept a parameter in our function component, and in every function component, we can accept that parameter. And that parameter is typically called props. You can name it whatever you want, since it's your code, but it's called props because this React concept is called props. This will be an object, props will be a JavaScript object, where all the attributes added on the element are in the end available as key value pairs in this props object. So here, these attribute names will be the keys, and the values will be, well, the values. So props inside of the to-do component will be an object now that has a text property and then different values for this text property. And if you named this attribute differently, that's also okay. You will then have a property of that name in your props object. So therefore now here in this h2 tag, we want to output this text we're getting on this props object. Now in standard JavaScript, we access object properties with the dot notation. So we could output props.text here to access the text property in the props object and therefore the value stored in this property. But if we do this here, we just see props.text as our output. The reason for this is that everything here in this JSX block is treated as HTML elements or plain text. The good news, however, is that we can also output dynamic expressions as part of the JSX code. We can tell React that something should not be treated as plain text, but instead as a JavaScript expression that should be evaluated. And we do this with a special syntax inside of this JSX code, which looks like this. Opening and closing curly braces, single curly braces. And between those braces, you can have any JavaScript expression you want, like for example 2 + 2. Now this will not be treated as plain text, but instead it will be executed as JavaScript. So if I save this, we see 4, the result of this expression. Now you can have any single line expression in here, but you can't have any block statements here. So adding an if check here would not work. But what does work is referring to props.text here. So simply outputting the result of accessing this text property on the props object. If we add this code and save this, we see our different texts here for the different to-dos. And now we build our own truly reusable React component here the to-do component. It is truly reusable because now it does not just have some hard-coded structure and text inside of it, but also some dynamic code using this core concept built into React, the props concept, for accepting data from outside, so from the place where it is being rendered. That is a key concept, this props concept, and that is how you build reusable custom elements, reusable components. And that's therefore a major first step here. Now let's make sure that we handle events, that we handle a click on the delete button, and that we then also change something on the screen when the button is clicked. To be precise, that we present this nice overlay when that delete button is clicked. So let's now make sure we can listen to a click on this delete button. In vanilla JavaScript, so in just JavaScript without React, we would find a way of selecting this button, for example with document query selector button. And then once we got hold of this DOM object, we could add a click listener with add event listener. Now this is again an imperative approach. We describe what should happen. With React, we rather use a declarative approach describing the target result. And hence this is not code we write in React. Instead, with React, if we want to listen to a click on this button, we add an extra attribute on this button. And for this, it's important to understand that all these default HTML elements are in the end also just React components. Just React components that are built into React already. So they look like regular HTML elements and you use them like regular HTML elements, but under the hood, these are components. And that matters because that means that you can add certain attributes which you could not add like this, at least with just HTML. For example, on a button, or actually on any HTML element here in JSX, you can add an onClick attribute written like this: lowercase o, uppercase C, and the casing does matter. Unlike in regular HTML, here it does matter. Now when you add the onClick prop, as it's called, as you learned, to a button or to any other element, you're telling React that you want to react to a click on that element. Now, the value you assign for this attribute is then not some text, not a string, but instead a dynamic expression which should hold a function that should be executed when a click occurs. So here we could define an anonymous inline function like this, or also with the arrow function syntax, which you can use in modern JavaScript, or you point at another function. And I'll do the latter. I'll create a new function, and, important, I'll create it as a nested function inside of the to-do function. And that might look weird, but that's actually standard JavaScript. In JavaScript, also without React, you can define functions inside of functions. So here I'll add a function inside of the to-do function, inside of that to-do function component, and we could name this delete handler. The function name is totally up to you. I personally like this convention where functions which are executed upon events end with handler, but other people don't use that, but instead might use handle delete or just delete. Totally up to you. I'll go with delete handler here and then point at this function as a value here for this onClick prop, simply by repeating the function name here. And now here is an extremely important thing to keep in mind. You don't execute the function here, so no parentheses. If you would execute it here, this function would be executed as soon as JavaScript and React evaluates this code. So when this line of code is evaluated, the function would execute. Now that is too early though. we want to execute the function when the button is clicked, not when that code is evaluated by JavaScript, because that happens right before that content is rendered in the browser. Hence, we just point at this function by just using its name here, and that just tells React in the end that it's this function that should be executed when this element is clicked. And now in here, we can do whatever we want. For example, we can console log clicked here for the moment. And if we do that and save this, if I go to the JavaScript console in the DevTools, if we click one of these delete buttons, doesn't matter which one you click, you see clicked. Now we could also output clicked and then as an extra log props.text, so that text value which we receive via props, which I also output down there in the h2 tag. I'm now referring to it again here, because this is just standard JavaScript in the end, even though this JSX code definitely doesn't look like it. But up here, we write standard JavaScript, and hence, of course, here we can also use one of our arguments. And if that argument turns out to be an object, which props is, we can also drill into that object here. And with that, if I save this and click delete, you see the proper text being output here as well. And maybe it's not clear here, but that's another strength of React. Without any extra work from our side, these 3 different buttons are doing different things. I mean, they're always doing the same thing. We just defined this logic once, but the concrete values with which they work, the concrete text which they output is not the same. Instead, it's different for every button. And that means that we can easily write logic that's specific to a specific to-do, whilst still being able to define this logic once instead of 3 times, which is great and makes our code way more reusable. But of course, here the goal is not to log something to the console. Instead, we want to show a little overlay when that button is clicked. And for this, of course, we need to, first of all, create that overlay. We need to create the HTML code that should be showing up. And then as a second step, we also need to find a way of showing it conditionally. Now let's start with creating the code for the overlay. For this, I'll add a new component. We could add the code in the existing component, but it is considered a good practice to put every building block into its own file, every component into its file, and to avoid very long JSX blocks by instead splitting it up into separate components. Now, when you should make a split, that's something which will come with experience, and you'll see a couple of examples throughout this course here. But in general, you want to keep your component functions small and maintainable. The JSX code that belongs to a component shouldn't become too complex. And therefore, I'll add a new file in the components folder, and I'll name it modal.js, because that's the component that should be responsible for rendering a modal, this overlay. That's typically called a modal. And in here, we therefore create another function, the modal function, and we export this function like this. And here we can also accept this props parameter. As I mentioned, every component function gets this parameter. It's passed in automatically by React. But of course, if you don't use this parameter in a function, if you don't use it in a given component, you can also omit it. And here, for the moment, I will omit it. Then we need to return something here, something which can be rendered by the browser, as we learned. And for me, that will be another div. And in that div, we can then have a paragraph, let's say, with a text of "Are you sure?" or something like this. And below that, let's say 2 buttons. One button where we say cancel, and one button where we say confirm. Now in this demo, the buttons won't really do anything except for closing the modal. But of course, in a bigger application, you could then trigger different actions based on which button was clicked. But again, that's just a first demo. We're going to see a slightly bigger app thereafter in this course. So for the moment, it's this div. Let me format this with a paragraph and 2 buttons. Now, we want to add some styling. So on that div, I'll add a class name, as you learned, of modal. And on the buttons, I'll also add some class names. On the cancel button, it's button, and then another class named button dash dash alt. And these are simply classes defined in the index CSS file I provided to you earlier. And then here on the second button, it's just a button. And that's now the markup for this overlay component. Now, in addition to this overlay, we also want to have a backdrop, some gray background behind the modal, which blocks interaction with the page whilst the modal is opened. And for this, I'll add another component, the backdrop component in a backdrop.js file. And that will also be a straightforward component, simply a backdrop function here like this. And then we export this as a default. And here, I just want to return a div with a class name of backdrop. This div has no content, and therefore we can write it as a self-closing tag, actually. In standard HTML, you would not write it like this. Their divs are not void tags. But in JSX, you are allowed to do that if you have no actual content between the opening and closing tags. And here I just render this div because of this styling, which is added by this class, and hence I need no content, and hence we can write it like a self-closing tag. Okay, so now we got the backdrop and the modal. Now we can use both, and for the moment, we will always show both. So for the moment, we can go to app.js, for example, and below all these to-dos, we can now also output the modal as a self-closing tag like this, and the backdrop as a self-closing tag like this. And we again need to import these two component functions in order to use them here. So we import modal from /components modal, and we import backdrop from /components backdrop like this. If you now save all your files, you should see something like this. Let me zoom out a bit. Something like this. This is our modal. And at the moment, it's always visible and we can't close it. Because that's now one big missing piece. We know how to build components, how to build reusable components, and how to build our interface. But at this point, our interface is 100% static. It never changes. What we output here, that never changes. No matter how we interact with it as a user, the interface always stays the same. And of course, that's typically not what you want in a web interface. Things should be interactive and things should change. That's one of the main reasons for using a library like React. And therefore, let's now explore how React makes sure that we can change what we see after the page was loaded. In order to change what's visible on the screen, we need to change the state of this app, so to say. Now, attached you find an extra article and video which I created where I explain what state is. In the end, you can take it quite literally though. The current state of this application is that we have 3 to-dos and this overlay is open. Now, we would like to also be able to present another state where this overlay is closed. And we want to switch between the states. When we click on delete, then it should open. And when we click on cancel or confirm or the backdrop, it should close. So that should be our ways of switching between the states. And React has a built-in concept that helps us with that. And conveniently, it's called state. For this, let's go to our to-do.js file, to our to-do component. Here we got this delete handler, this function which is triggered when the delete button is clicked. When it is clicked, we would like to switch to the state where the modal is open. To make that happen, we need to import some functionality from the React library. So we import from React. Important here, we have node./ because React is a third-party library. You import from those by just referencing the library name. And then we import something like this with curly braces. We import the useState function. That is a function exposed by the React library, which we can use in our component functions. With useState, we register different states which we want to support in our React application, and React will react to changes in that state and allow us as a developer to render different output depending on which state is active. Now, that all starts with calling useState directly in our component function like this. So not inside of the delete handler, instead directly in the component function. useState is a so-called React hook, and those React hooks can only be called directly in React component functions and in custom hooks, which is a topic we'll not discuss in this course, but which is discussed in depth in my complete guide as well. For the moment, it's enough that we know that we can use React hooks in React component functions. Now, calling useState creates a state React is aware of. Now, we can give this state a starting value by passing it here as an argument to useState, and that could be false if our state is that we want to control whether the modal is open or not. And initially, it should not be open, so the initial state is false. Now, useState always returns an array with exactly 2 elements. That's how useState works. It always returns an array with 2 elements, and we can store this returned array in a constant, or we use array destructuring, which is a JavaScript feature, to store these 2 elements, since we know that it will be always 2 elements, in different constants. And we could give the first constant a name of show modal or modal is open or anything like this. And the second element here, the second constant, a name of set modal is open. Now, why did I choose these names? Because the first element, which useState returns in its array, is the current state snapshot. So this value, which is stored in this state. You can think of React state as a variable which is managed for you by React. You define the initial value here, and you will then also be able to change that value. Now you get access to the currently stored value through this first element here. The second element is a function that allows you to change that value. Because you don't change it by assigning a new value to modal is open, instead you always call this second function to assign a new value. Why does this matter? Because whenever you call this state changing function, React will in the end re-execute the component function to which this state belongs and re-evaluate it, and also update what's rendered on the screen. This allows you to pick up the latest state value and possibly render something different depending on the state. Now, this might still be a bit abstract. It will become crystal clear in a couple of seconds. What we can do now with these 2 elements is that in delete handler, we call set modal is open and set this to true to change that modal is open state from false, which is our initial state, to true. And then we use modal is open to conditionally render the modal and backdrop down there in this JSX code. So I go to app.js and I remove modal and backdrop from there and remove the imports since we're not using modal and backdrop in this file anymore. And instead I'll go to to-do.js and import modal there from /modal and import backdrop here from /backdrop, constructing the relative paths to these files as seen from inside this to-do.js file. And since modal and backdrop are neighbors to this file, the paths look just like this. And then we can use these components down here, let's say here in that div, modal and backdrop. Now, if we add it like this, they would always be rendered. I only want to render them if modal is open is true, if that state has a value of true. Now we are changing the state here. To use it, we can simply output a dynamic expression down here and check if modal is open is truthy, like this, and then write a ternary expression where if this is true, we render modal, And that might look strange, but that is code which you can write, else we don't output anything. So we render null. This certainly looks strange, but that is how you can render content conditionally with React and JSX. In these dynamic expressions between the curly braces, you can again use JSX, and that's what I'm doing here. So I'm checking if modal is open is true, and if it is, I render the modal, otherwise I don't render anything. And we can actually use a short trick or shortcut here and use the double ampersand, the logical AND operator here, like this, to simply use the fact that in JavaScript, if you use this operator, if both conditions are true, the second value will be returned. So if that is true, and that is true, and a function, a component function will always be true, then this component function is output here. And that's simply shorter than writing this ternary expression. We can now repeat that modal is open check here for the backdrop, and with that, we only output modal and backdrop if modal is open is true, and not if it's false. And we do this for every to-do component. So if we save this file as well now, we don't see the modal right now, but if we click on delete, we see it. And now we can't interact with the rest of this page because of this backdrop. So that's a great step forward. How can we now get rid of that modal though? To get rid of the modal and the backdrop now, we need to change the state again. From set modal is open true to false. We need to call set modal is open again and pass false as a value. The problem just is, when do we want to do that? We want to do that when the backdrop is clicked or when the cancel or confirm buttons are clicked. We don't want to do that if the modal itself is clicked, for example. Now for the backdrop click, you could think that on backdrop, you simply add on click again, and then we add a second function here, the close modal handler, let's say. And there we call set modal is open and set this to false. And then we point at this close modal handler here as a value for on click, just as we did it with the button in the end. But that won't work. If we save that and I reload, I can click the backdrop the entire day, the modal won't close. The reason for this is that the backdrop, like the modal, is our own component. These are not built-in components. So they don't know the on-click prop. Our own components have to be configured 100% by us. They have no built-in props which we can use. To be precise, they actually do, but only for some very special cases and not for event listeners like this. So if we want to make sure that an on-click prop exists in the backdrop component, we have to add code to this component function to support this prop. And for this, we can go to the component function and accept this props argument here, this props parameter. And then here, we can, of course, work with an on-click prop or any other name we want. It's totally up to you because it's our component. But here we can, for example, expect an on-click prop because I'm setting this here in the to-do component. And we actually expect a function as a value on this on-click prop. Because in the to-do component, I do pass in a function in the end. I point at a function, which means I pass a pointer to the function as a value for this prop. Now, in the backdrop component, we actually want to call this function, which we receive on the on-click prop, when this div is clicked. Now, the div is a built-in component again, so it does have on-click prop. And now we could simply point at props on-click as a value here. By doing this, we would in the end forward the function which we receive on our props here, on our on-click prop, into that div on its on-click prop. And these names don't have to be equal. We could expect an on-cancel prop here instead, and in to-do component rename this to on-cancel. It's our component, so we can name this however we want. Now, if we do that and save all the files, if I reload, now we can close the modal by clicking the backdrop. Because now we're using a prop to pass a function as a value. And that's a pattern which can be confusing and might look strange at first, but keep in mind that in JavaScript, functions are first-class objects. You can pass them around as values just as you can pass strings and arrays and objects and numbers as values. Hence, you can pass a function as an argument to another function and therefore also as a value for a prop to another component. And then that function which we receive in that component can be executed in that component, or, as we're doing it here, it can be forwarded to yet another element, another component. Now we can use that same approach in the modal component for canceling and confirming. There we could add functions like the cancel handler and then let's say the confirm handler, and kick off different logic depending on which button was clicked. But in this case, I'll simply, in the end, run the same code in both functions. Nonetheless, we can bind the first button with the onClick prop to cancel handler. And here it has to be onClick because that's not a custom component, but a built-in one. So here we can't come up with any other name. And for the confirm button, I'll also add onClick and point at the confirm handler. And now in these functions, we can run any code we want. In this case, though, I also want to just close the modal. So again, I'll just accept the props parameter here. And in cancel handler, I'll just execute props on cancel, let's say. In the confirm handler, I'll execute props on confirm. And hence, instead of defining these functions here and pointing at them here, we could have also just forwarded props on cancel here like this, just as we did it for the backdrop. I'm just showing this alternative approach to make it crystal clear that you can execute these functions which you receive through props. You can forward them to other elements if that's what you need to do, but you can also execute them anywhere in your components. And hence, I'm using this alternative setup with these extra wrapper functions, at which I then point here. And now we got an onCancel and an onConfirm prop, which are expected on that modal component. So in the place where we use the modal component, we should add onCancel and onConfirm. And here in both cases, I'll just point at the close modal handler, because as mentioned before, here I got no special logic, I just want to close the modal. With that, if we save this and reload, we can not just close the modal by clicking the backdrop, but also by clicking cancel or by clicking confirm. And that works for every to-do here. For all to-dos, the modal works in the same way. And that's therefore another very important building block of React. Props are important for building reusable components. State is important for changing what we see on the screen dynamically, for adding or removing elements, for changing text on the screen, or, like in this case, for showing and hiding an overlay. So now that we picked up those important React basics, it's time to dig a bit deeper, to dive into some advanced concepts like routing, sending HTTP requests, and application-wide state management, and what all these things are. We're going to explore that. And for this, we're going to leave this basic project, this basic demo we worked on. Instead, we're going to build this meetup demo application I showed you earlier already. And for that, I cleaned up my project. I removed basically all the imports and all the content from this app file here. And index.css has some new content. You find my updated project attached. So there you also find the updated index.css file. And I deleted all the components. Now, as I just said, you find this updated starting state attached, and you can therefore then start with that same project. In the end here, once you downloaded it, you need to run npm install again. Then once that's done, you can npm start this project again to bring up that development server again. And that will give you a blank page. Because now we're going to build this project from the ground up, and this project will now involve more components than the previous one, and it will involve the important concept of routing. Now, what does routing mean? Consider this Netflix example from before again. There, I went to the My List page to view the items I added to my list. Now, it looks like I visited a totally different page, but if you watch this refresh icon in the top left corner, you see that it never changes. It never goes into that loading mode. Because actually, we never fetched a new HTML page. The page loaded by the browser never changed. We always stay on that single page. And that's the case for Netflix, because they also have such a single page application. It should also be the case for our project now. I want to give the user the illusion of having different pages to which we can navigate, whilst actually staying on one and the same page and leaving it up to React to change what's visible on the page. The advantage of this approach is that we never have to wait for a new page to be loaded. Instead, we can always stay fast, stay reactive, because everything is handled by client-side JavaScript, which is faster than sending a new request to a server. And that can really enhance the user experience. Now, therefore, we want to add something which is called routing to our project. We want to add a router. A special tool which actually watches changes in the URL and then changes what's visible on the screen based on the URL. So which basically gives us a way of giving our users this illusion of routing. And for this, I'll actually quit this development server again and install a new dependency, a new third-party package into this project. We do this with npm install, with the npm install command, but now not just executed like this, but instead we now add a package name thereafter. The name of the package which should be installed, so downloaded, into this project here. And that's the react-router-dom package. That's a package which, as the name kind of implies, allows us to add routing functionality to React. So it allows us to handle URLs and change what's visible on the screen without fetching new HTML pages. Simply hit enter, and this package will be installed. And in package.json, you'll see that a new entry was added. So that file was automatically updated, which means that if you now share this project again without a node modules folder, and someone then runs just npm install again, that newly added package will also be picked up and installed because it is part of this package.json file. Now we don't need to do this here because we just did install it. So we can run npm start again to bring up that development server again. And now we can add routing. But what does this mean? What does add routing mean? In the end, it means that we need to add this routing tool to our code so that we have this thing watching for URL changes. And we need to let this thing, this tool, know which component should be loaded as a page for which route, for which URL. And for this, I'll start by adding a new folder next to the components folder inside the src folder, and that's the pages folder. You don't have to add this folder and you don't have to name it pages, but in the end here, this is a good way of differentiating and of separating our components that are embedded in other components, which will be stored in the components folder, from the components that will be loaded as pages. Technically, we'll build components in the same way, no matter how we use them. But for us as a developer, to have an easier time to quickly find the right component we want to work on, I'll separate them into these two folders. And in the Pages folder, we're now going to add a couple of React components, which again will be built just like all the other components, but which will be loaded by this router we just installed when certain URLs are visited. And here for this application, for this project we're building here, I'll add a all meetups.js file. So a component that will be responsible for loading and displaying all the meetups we have. I'll add a new meetup.js file, and I'll add a favorites.js file. New meetup will allow us to add a new meetup later, and favorites.js will allow us to view our favorited meetups, because we'll add a functionality that allows us to bookmark, to favorite a meetup as a user. But step by step, for the moment, I'll just set up some dummy components in these three files. And I'll start with all meetups, and I'll name this component function all meetups page. You can name it however you want. I'll just choose this name to make it clear that this component will be used as a page that's loaded by this router. Now, just as all the other components we built before, this component has to be exported, and it needs to return some JSX code. And for the moment, I'll just return a div where I say all meetups page. That's of course not the final content, but some starting content for now. Then we can copy this and add it in the favorites file here. So this is the favorites page, and we want to export the favorites page. And here I'll then say favorites page, and then save this and copy this into new meetup and name this new meetup page, and also use that name for exporting. And here we say new meetup page. Now we got these three page components. Now we need to use that router package to define when which page should be loaded. And for this, we first of all need to go to index.js and wrap our app component, which we render here, with another component. For this, we need to import something from react-router-dom, and that something which we import is the browser router, like this. Now it turns out that browser router is in the end a component itself, and therefore we can use it as a HTML element, opening and closing tags, and wrap those tags around the app component. Now that is something we haven't seen up to this point, that a non-standard component, so a non-HTML component, would be wrapped around something, but it is something we can do, and it is something we are doing here. We're going to learn how we make our own components wrappable a little bit later in this course. So now we initialize this router package. We make it aware of this app, and we ensure that it watches our URL, so to say. Now, as a next step, we need to define the URLs we want to support and which pages should be loaded for the different URLs. And we do this in the app component now, so in this wrapped component. In there, we return a div, and we can leave it like this. But now in this div, I want to return or use other components which are also imported from React-Router-DOM. So we also import React-Router-DOM here, and here we import the route component. So just like browser router, route is a component, and we use it like a component, but the job of the route component is to define different paths in the URL we want to listen to, and which component should be loaded for these different paths. And therefore, I will also already import my three page components here, the all meetups page from /pages all meetups, and then the new meetup page from .pages new meetup, and of course also the favorites page component from /pages favorites. And now in this div here, we can use the route component, which I'm importing from React Router DOM, and give it a path prop, a path attribute. Now path takes a string, and that will be the path in the URL after your domain. So in our case, our domain is, for example, localhost 3000. That's our domain. Of course, on a real server after deployment, that would be something like mypage.com. And now the part after the domain is the path. That can be just a slash, so no path at all in the end, or it can be something like /favorites or /products or anything like that. So the part after the domain is the path, and here we define for which path which component should be loaded. And here we can start with /nothing to handle the default path that we just visited our domain /nothing. And then between these route tags, we actually do now add the component that should be loaded, like the all meetups page like this. Because that should be the starting page actually. We can add another route here for, let's say, /new-meetup. And the path is up to you. If we now visit mydomain.com/new-meetup, then the component which we render between these route tags will be loaded. And that could be the new meetups page. And last but not least, we can also define a route for the path /favorites and then render the favorites page like this. Now we're defining 3 routes, and instead of this content here, the actual page component will be rendered if that route determines that the current URL matches this path. So if we are on mydomain.com/new-meetup, this new meetup page component would be rendered and not the favorites page, for example. So if we save this and we go back and reload localhost 3000, we should see the all meetups page here. But if we go to favorites, for example, we see favorites page as well. But wait a second, is this the desired result, that we see it as well? Well, it depends. In some applications, depending on what you build, you might want such a nested page so that the page for just /nothing is rendered, but also this specific page for /favorites. We see this output because by default, React Router matches all your paths, and it simply checks if the current path includes these paths here. And /favorites includes both /favorites as well as just /, which is why both components are rendered. Again, that could be what you want, but often it's not. That's why there is another component provided by React Router DOM which helps us, and that's the switch component. We can use the switch component to wrap all our route components like this, and with that we tell React Router that only one of these routes should be active, so at most one of these pages should be rendered. If we do that and save this, we don't see 2 components being rendered, but we don't see the correct component being rendered either. Instead, for /favorites, we now see all meetups. And the reason for this is now how your routes are matched. React Router by default checks if the path of the current URL starts with the paths defined here. And because of switch, it will then stop looking at the other routes as soon as it has a hit, as soon as it finds a match. Now, of course, /favorites starts with just /, and then because of switch, it doesn't look any further, and therefore all meetups is rendered. That's not what we want, and we can prevent this by adding the exact prop here on route and setting this to true. Though you can also shorten this, and if you have a prop which you just want to set to a truthy value, you can just add the prop name like this. So we add the exact prop and set it to true to this first route. And the exact prop tells React Router that for this route, it should not check if the path begins with this path, but if the full path matches this path. And that's now, of course, not the case for /favorites. So this will not create a match, and it will continue looking, and it will ultimately find this route for /favorites. So now we see the favorites page. For new -meetup, we see the new meetup page. And for just localhost 3000, we see the all meetups page. And that's how we can add routing. But of course, at the moment, we're just navigating around by entering URLs manually. And that's not very realistic. In reality, we would probably want some header, some navigation bar at the top, which provides different links. And therefore, that is what we're going to add next. Now let's take care about adding such a navigation bar to our application. And for this, I'll go to the components folder and add a new folder in there. And I'll name it layout because it will hold some general layout components. So a subfolder inside of components. And in there, I'll add the main navigation.js file, which is the file that should hold this main navigation component. Now I added it here in the components folder and not in the pages folder because this component will not be loaded as a page with help of the router, but instead we will embed it in the content of our other code just as we did before, totally unrelated to the router. Now in this main navigation component file, we can again define our component function, main navigation, and export it as we're used to, and then of course return some JSX content here. And here I want to return a header component, which in the end will then wrap all the items that should go into this header. And here I actually want to have a div first with my logo, which in this case will just be some text. I'll name it React Meetups. And then next to this div, inside of the header, I'll add a nav element. And here I'll then add an unordered list with a couple of list items, where all those list items will be the different links which we have here. Now, when it comes to those links, we typically render links by using the anchor tag. That's how we do that in standard HTML. We could do this here as well, but using that link component, that link element, has one big disadvantage. If we use a link like this, whenever we click it, a new request will be sent to the server. The server here is the server hosting this React application, and indeed that server would then reply with our application, and there the router would figure out which page to load. So a link would work, but we sent this request first, which is redundant. We already are in our running React application, and it would be great if we don't leave it just because we want to navigate somewhere. Hence, sending that extra request is not something we necessarily want to do. That's why instead of this anchor tag, we instead use another component provided by the React Router DOM package. So we again import from React Router DOM, and we import the link component here. The link component can be wrapped around our link text, just like the anchor tag, and it will render an anchor tag in the end, but internally, React Router DOM attaches a click listener to the anchor tag, and when you click on it, it will prevent that browser default of sending a request, and instead just parse the URL you want to go to, change it in the browser URL bar, but then not send a request, but instead load the appropriate component onto the screen just with React and JavaScript, so that we stay on this already loaded page and we don't send this extra request. So that's why we add links like this. Now, of course, here that should not be some link, but a link to all the meetups, let's say. And to make link aware of the URL it should navigate to, we have to set the to prop here. This is one of the expected props on the link component. And here we set a path, in this case just /nothing, because that is the path to the all meetups page. Now we can replicate this and add 2 more list items where the second one leads to /new meetup and says new meetup, or add new meetup. That's up to you, of course. And on the last link, we go to /favorites and we say favorites or my favorites, something like this. Now we got those links in place and we got this main navigation component. We can now use this in the app.js file, and there we can now import main navigation from ./components/layout/main navigation and add this above that switch statement. Here we can add main navigation as a self-closing tag still, if we want to. If we save this, we'll see some navigation here. And if we click those links, they work. The styling is missing, but we got working links. We got a working navigation. Now I want to add some styling, and for this we're going to explore a different way of styling our components. In the first demo application we built, I gave you one CSS file that contained the styles for all components. That works for a small demo, but not necessarily for a bigger project. There, you typically want to have different CSS files for your different components. And hence the CSS file which I provided to you here is very slim. Now, when it comes to styling the different components, it would be even nicer if the styles set up in a specific CSS file would then be scoped to the component to which they belong. So it would be nice if next to main navigation, we could add, let's say, a main navigation.css file and then define the styles in that file that belong to this main navigation.js file. And they should not affect any other component. That's something you often want because in bigger React projects, you often work with hundreds or thousands of components, and you want to make sure that your styles don't clash with each other. Now, the good thing is that Create React App, this tool which we used for creating this project, gives us a project that has a feature built in that allows us to scope styles to components. And that feature is called CSS modules. It's a behind-the-scenes code transformation which will make sure that we can attach CSS files to specific components. For this, we first of all need to name our CSS files in a certain way. We need to make sure that they end with .module.css. So in this case, the file is named main navigation.module.css. And then in main navigation.js, we can import from this CSS file. That certainly looks strange, and it's not something that would work in standard JavaScript. But since we have this extra build step here, which parses and transforms our code before it reaches the browser, we can actually import from CSS. And that is what we're already doing in index.js, by the way. We're importing a CSS file, and behind the scenes, that will tell the build process that this CSS code should be injected into the loaded page as well. We can do the same here in main navigation.js, but now to attach this styling or this style file and its classes to this component, we don't import just main navigation.module.css like this, but instead we import something, for example, classes, this name is up to you, from this file. Now I named it classes because this something here, which we import, will actually be a JavaScript object where all the CSS classes you define in this CSS file will be properties of this object. And you can then use them in your JSX code to attach those classes to your elements. And behind the scenes, everything will be transformed such that those class names are made unique per component. So let me give you an example. We could go to the header JSX element here and add the class name prop and set this not to a hard-coded string, but instead to a dynamic value with curly braces and set it equal to classes.header. Now we can add a class named header, because here I'm accessing header on classes, to this CSS file. And any styles we define in here would then only affect this component here. So if I save this and I gave this a red color, you see now that's colored red. And if I had another header class in another component, it would not be red because the styles are scoped, as I just explained. Now the goal is here not to make this red, but instead I prepared some other styles for you, which you find attached. You find a main navigation.module.css file attached, and you can simply replace your main navigation.module CSS file with mine. Now in here I defined a bunch of styles for you, and therefore we now just have to wire them up to the elements. We already added the header class to the header. On this div with the logo text, you should add classes.logo, and that's actually it already. And with that, if you save this, let me zoom out a bit, now we got this good looking navigation bar at the top here. By the way, it's not optimized for mobile, since this is not really a CSS course, but I want to focus on React instead. But now with that, we added this nice navigation bar, and we added it such that we have component-specific styles, which are also scoped to this component. Now that we added our styling in our navigation bar, let's work on the pages. Let's maybe start with the all meetups page, and let's output a list of dummy meetups for the moment, before we then make sure that we can add our own meetups. Now for this, I'll go to the all meetups.js file, and the goal in there is to get a list of meetups. Later, we will get it from a server by sending a HTTP request. For the moment, we'll work with some dummy meetups, and I then want to output those meetups. Now for this, I'll first of all add a constant named dummy data, which we'll replace later, which holds an array of dummy meetups. Now here I'll just add a bunch of JavaScript objects which hold the meetup data. Things like the image, the title, the description text, and the address maybe. And for this, you can definitely also use my code attachments. There you'll find some prepared dummy data. You can also prepare your own one. Here I just have two dummy objects, which have basically the same content, just different IDs and different titles, but the same image, the same address, the same description text, because of course it's not about the dummy data, but about what we do with it. Now one word about that image. I got that from Wikipedia. You can of course bring your own images. Here I got this nice looking image here, created by Thomas Wolf and not by me, so just to give him due credits. And you can of course bring your own image, just make sure that you simply get a URL to some image and store that in this image property of your dummy data points. Now we got the dummy data, now the goal is to output that data. So for this here in this div or a section, which we could also use, we can add a h1 tag, let's say, and say all meetups. And then below that, we want to output this data, but of course not as code like this, but instead as JSX elements. And for this, we now need to learn how we can render a list of JSX elements dynamically, how we can translate a list of data into a list of JSX elements. Because it is worth noting that in JSX, you can actually render an array of JSX elements like this. So output a dynamic expression with curly braces, then add an array, and in there you could have list items like item 1, and then as a second item, item 2. And if you do that, those are rendered. So arrays are rendered correctly automatically by React. And that's important to know, because that means that if we can translate this array of objects into an array of JSX elements, we can output it down there. And there is a way for translating an array into an array of different data in JavaScript. On that dummy data array, we can call the built-in map method, which exists in JavaScript. And map allows us to execute a function, here I'm writing an arrow function, on every element in that array, and it will get this element as an input. So in this case, the meetup, let's say, as an input automatically, because this function is called automatically by JavaScript. And we then return the transformed data. And the result of calling map then is a new array full of that transformed data. And here we could say for every meetup object which we're getting, we want to return a list item. And hence we maybe actually wrap this all here with an unordered list. And in that list item, we want to output data about that meetup. For example, to begin with, to output the title. So here I'm dynamically outputting meetup title in this JSX code. So with that, we transform our array of objects into an array of li elements. And if we do that just like this, and we reload, we see this is a first and this is a second meetup. So that does work. Now there is one important note about lists though. If you open the developer tools, you'll see a warning here that each child in a list should have a unique key prop. That is a requirement by React, which it needs to update and render lists efficiently. I dive deeper into that in my React course. For the moment, it's enough to know that we should add the key prop here to the list item and then set this to some unique value per item. And we have a unique value for every list item here, the IDs. The IDs are different for every item. So here we can then set this to meetup.id. And with that, we'll no longer get that warning if we reload. So that is how we can render a list of data, simply by mapping it. And that is how you typically do render lists of data with React. But in the end, you can just render any array of JSX elements, no matter how you derived that array. Now, rendering our list like this is of course not our goal. We want to render a more beautiful, a more good-looking list. And for this, we could structure our code here differently and add more styling. But ultimately, I simply want to create a new component here and add component-specific styling. So that's what we'll do. In the components folder, I'll add another subfolder next to layout, and I'll name it meetups. And this holds all my meetup-specific code. And in there, I'll add a meetup item.js file and a meetup list.js file, because I want to outsource both the list as well as the individual list items into components. Because, as mentioned earlier, it is a good practice to split your components and your application as a whole into small, reusable pieces. Now let's start with the meetup item. In that file, we create our meetup item function, of course, as we did before, and we export that function. And then in here, we return a list item. And then in that list item, I want to have a div in which I render the image and set the source to something and the alt text to something. And then that's a self-closing element. And below that div, I have another div with the content, where I have a h3 tag with the title, an address tag, which is a default HTML tag, where I output the address later, and then a paragraph with the description. And all this hard-coded text will, of course, soon be replaced with dynamic data. And then below that, we can add another div with a button where we say to favorites, so that this adds the item to our favorites later. That's the general structure I want to have here. Now, as mentioned, title, address, and description, and also the data for the image should be dynamic. I don't want to hard code it here. Instead, it should be passed in from outside, from the so-called parent component, so the component where we use this component in its JSX code. And we learned how we can make that happen. We can accept props here and use props. And then, for example, for the image source, we could set this to props.image, expecting an image prop on the meetup item, which holds that URL that should be set as a source here. And the same for the alt text, that could be our title. The title can also be used down there, so that we output props.title here. And for the address, it's props.address. For the description, it's props.description. And now, all of a sudden, this component is reusable and dynamic. Some styling would also be nice, and for that, again attached, you find CSS files here, the meetup item.module CSS and the meetup list.module CSS files, which you can copy in next to these JavaScript files. And then in meetup item.js, we want to import classes from /meetup item.module.css and assign a couple of classes in that JavaScript file. On the list item, for example, we'll add the item class like this. On this div, which is wrapped around the image, we'll add the image class like this. On the div, which is wrapped around the title and description and so on, we'll add the content class. And then down there for the button, I'll add a class of actions like this. Now that's not all. I also want to work on that meetup list component already. So here we can again create another component, meetup list, and export that as a default. Also accept props here, because I expect to get that list data from outside as well. And I'm expecting this because I'm the one building this app. We could also write the code for fetching meetups in this component, but I instead want to make this component reusable and not care about the data source in here, but instead just expect that I get meetups through some prop, and then it's the component which uses the meetup list component that has to worry about getting the meetups. And I'm setting it up like this because I plan on using the meetup list component in the all meetups component and also in the favorites component later. And there we'll have different data sources, but the same way of displaying the data. And that's what we can make work by adding a separate reusable component. In here, I also already want to import classes from /meetup list.module.css and return an unordered list here, which receives a class name of classes.list, which is one of the, or the only provided CSS class for this component. And inside of the unordered list here, I now want to output my meetup items in the same way as we did it in all meetups, by mapping an array of objects into an array of JSX elements. Just that the JSX elements will now be the list items. And for this here, we again add a dynamic expression with curly braces, and we can expect that on our props here in meetup list, we get, let's say, a meetups prop. The name is up to you because it's your component. This could also be named items, but here I'll go with meetups. And then I map every meetup into another object, into a JSX element to be precise. So therefore, using the arrow function shorthand syntax here, I'll transform every meetup into a meetup item. And for this, you need to add this import. It was automatically added for me here by the IDE. If that does not work for you, just add it manually and import meetup item from the meetup item file. Now we render one meetup item per object in the meetups array, and that now needs to be configured. It needs this key prop, this special prop React expects, one of the very few special props that are built into React and that can be used on any component, including your own components, without you writing any special code for it inside of your components. So you can just add that anywhere. And we set that equal to meetup.id. Then in my own component, I'll actually pass in the ID as well as an ID prop. We will use that later for the favorite feature. I'll pass in the image prop with meetup.image. Let me reformat this to make it a bit more readable. Add the title prop and point at meetup.title. And also add address and description. So meetup.address and description is equal to meetup.description. Now, alternatively, we could have also just passed in a meetup prop or any other name and just passed in the meetup as a whole. Then we would have to destructure it inside of the meetup item component. It's up to you which approach you prefer. Here I'm passing in individual props. With all of that done though, we can go back to all meetups and now use the meetup list component instead of the unordered list. So we go up and we import meetup list from going up one level out of the pages folder into the components folder, into the meetups folder to meetup list, and then just output meetup list like this, and very important, provide the meetups prop because we're expecting that prop inside of the meetup list component here. So set up the meetups prop here and pass in the dummy data array as a value. With all of that done, if you save all the files, you should see something like this. Now, this is not the final look. We'll continue tweaking this, but it shows that our content is being rendered, and that's not too bad. But now it would be nice to kind of restrict the width which we use on the screen, and it would also be nice if the individual meetups would look like cards with a nice drop shadow, maybe rounded corners, something like that. That's what we're going to add next. Now let's start with that card look. In case it's not clear what I mean that look which we also used earlier for the first demo project, where we simply have a nice white background and a slight drop shadow. And I'd like to have that for every meetup item. Now we can solve this by adding a couple of CSS classes in the meetup item module CSS file, and then changing the look of our list item. That would work. But this card look is so common that we maybe also want to use it in other components of this application. And we will actually use it in other components later. That's why I want to create a separate reusable component, which should act as a wrapper around other components and just give those components some styling, which we then reuse. And for this, in the components folder, I'll add a new subfolder, which I just want to name UI for user interface. The name is up to you, of course. In there, I want to store some general user interface components, which don't belong to a specific feature, but instead are used in different places of the app. And here I'll add a card.js file, and attached you find a card module CSS file, which you can simply add next to this card.js file. And in the card.js file, we'll now create a component as we did it before, simple functional component, and export it, of course. And we'll also import the styling, import classes from /card.module.css. And then in the component function, return a simple div where we set the class name to classes.card. Now, the special thing about this component is that this should now be the first custom component which we can wrap around JSX content. Because the goal is to use this card component such that on a meetup item, inside of this list item, We can use card, and for this you need to add the import. So import card from going up one level, diving into UI, card. And we can wrap card around that JSX content so that we can use the card component like this. That's the goal. But at the moment, if you save all files, the result is that you don't see anything. And the reason is that at the moment, this card component simply swallows everything we wrap and throws it away, you could say. Because this card component just renders a div, and it doesn't know what it should do with any wrapped content. Now, it's such a common case, though, that you build components that should wrap itself around more JSX content. So you could say that you want to inject JSX content into this component. That React, of course, has a solution for this case. And this solution, again, is related to props. We learned that we can pass props by adding attributes to an element, and that does work. But you can also add a special prop by passing content between the opening and closing tags. And that content is then exposed under that special prop inside of that wrapping component. So here we accept the props parameter again. And then between the div tags, I want to output props.children. Props.children is a special prop. The children prop is a special prop which every component receives by default. And children always holds the content which is passed between the opening and closing component tags. So this JSX content, that is the value stored in that children prop in this case, when we use card in this component like this. And now I'm just outputting the value stored in children between these div tags. And with that, if we reload, we now have this slight card look and we see a drop shadow here. Since we take up too much width, we don't see it perfectly, but we can see it a bit. And if we inspect this in the DevTools, we see that every meetup item here has this div with the card class. The name was transformed because of that CSS modules feature, but it has that div with a card class wrapped around these other divs, image, content, and actions, inside of the list item. So that wrapping works, and that is another very important technique when it comes to composing user interfaces with React components. And that's why we also cover it here. And we can now use this technique as well for setting up a general layout for this application. Because I'd like to have more white space around the content here. And for this, I'll go to the layout folder and add a layout component in there. Attached, you also find a layout module CSS file, which you can add next to this JavaScript file. And then here in layout.js, we can create a layout component function and export it as a default. And import classes here from /layout.module.css. And then in here, return our layout. And that could be a div with our main navigation, let's say. So from app.js, I'll cut main navigation and remove the import there. And instead in the layout component, I'll add that here. And therefore, of course, also add an import of main navigation from that main navigation JavaScript file, which is next to the layout file. And below that, we could use the regular main HTML element and then use the layout component such that we wrap it around the actual JSX code that should be rendered. So we could say that in app.js, we want to wrap the content selected and rendered by the router with our layout. So here in app.js, we can import layout from, going up, diving into the components folder, layout. And instead of having this useless wrapping div, we could use our own layout component for wrapping here. And now this content here, the actual route content, the page component that is being loaded, should be rendered inside of this main block. And we can again achieve this with props children. We can again accept props here and then output props.children here inside of the main element. And that will then just forward that content, which is between our layout tags, so this content here, into that main element. Now here we should also add a class name of classes.main for styling. And with that, if we save this, now we're utilizing this nice layout component for wrapping all our content. It's technically not required. We could have added the styling in another way too, but it is another nice practice of this children concept, and it removes some extra code from our app component and makes sure that this component can focus on one main thing, rendering the routing configuration. Because your components typically should be focused on one thing. And now we got a leaner app component, and we're again using props children to create this layout component here. Now that we're able to render a couple of meetups there with help of our meetup list and meetup item components, it would of course be good if those meetups would not come from our dummy data source, but from an actual server. And they should actually end up on that server because we created them on the Add New Meetup page. After all, that's the goal of this demo application. That on this add page, we have a nice little form for entering data about a meetup. So entering this kind of data in the end. And then that data should be sent to some server, to some backend, where it's then also stored in a database, so that then it can be fetched and loaded in all meetups. By doing that, meetups that are added here could be shared with all visitors from all over the world, since data is stored in a database on some backend server, not just in our browser. And the data would also be there if we reload the page. If we just store data in memory, any data is lost if we reload the page because the JavaScript application restarts and the previous state is lost. And therefore, the first step is to add this form to this Add New Meetup page so that then in a second step we can gather the entered data and send it to a server. And for this, we'll work in this new meetup.js file, which is the file that should render this meetup form. So in here, I'll actually also add a section and a h1 title of Add New Meetup. But then below that, I want to output the meetup form, which I will actually create and store in a separate file to, again, keep this new meetup page lean. Now, a good folder would be the meetups folder in the components folder. And therefore, in here, we can add a new file, the new meetup form file, for example, new meetup form.js. Now, attached again, you find a styling file for this file, the new meetup form.module.css, which you can just download and add next to this JavaScript file, so that you have some styles which I prepared for you. And in the new meetup form.js file, we now create another function because we're going to create another component, the new meetup form function and component, which just as before is exported here to make it available outside of this file. In the new meetup page component, below this title, we can then already add that new meetup form. Make sure you also add the appropriate import. Now, once you did add it, back in the new meetup form.js file, we can start with outputting the JSX code for the form. Now, I want to actually wrap this form again in this card to give it this card look. And that's why I created that separate card component before, so that we can now reuse that component. So now, besides using the card component in the meetup item component, we can also use it in the new meetup form simply by using it here. And of course, by importing it, you always need to import what you use in a file from the UI folder and the card file. Now, card will then be wrapped around the actual HTML form that we'll create, and then we'll, populate that form with various inputs. Now, I did provide that CSS file for the form, so let's also already import classes from /new meetup form.module.css to have these scoped styles. And we can start assigning classes on that form element where you should assign the form class like this. Now, inside of this form, you can of course structure this however you want, but to fit the styles which I provided to you, I'll add a div with a class of classes control. And in that div, I want to have a label where we say meetup title, for example, for the first input we're going to add. Now that input is added here and it's of type text. It should be required so that we have that in-browser validation. And I will give it an ID of title and then self-close it. And now connect this label to this input by adding the for attribute, but just as class, for is a keyword in JavaScript, and therefore the actual property name for setting this for value or for setting this attribute here is HTML4. So I add HTML4 as a prop, and that's another exception besides class name where you use an attribute name that deviates from the regular HTML attribute name. It's basically the only other important exception besides class name which you have to memorize. And then we point at title here. And this simply connects this label to this title for screen readers and other assistive technologies. Now we have this input with this label here, and we can now repeat this entire control div multiple times to also render a label for the meetup image, and maybe use an ID of image here and change this to type URL, since the image set here should actually be a URL pointing at an image. If you're interested in uploading files with React, that is not really that much of a React task, but mostly a backend server task, and hence I discuss file uploads in my Node.js course, for example. But to learn how to make file uploads work with React, I also have a resource attached, a tutorial, which you can take a closer look at to learn how to upload files with React. Here, we'll not upload files, we'll just insert the URL of an existing image, which already exists on some server. Then we can, replicate this div again for our address here, let's say, and the ID could be address, and here we'll again just have some plain text as an input type. And thereafter, I want to have one more control, which is the actual description of the meetup. And hence, we could use description as an ID. But here, I'll actually not render an input, but instead a text area, which is another default HTML element. It'll still get that ID description here. And it will also still get the required attribute for adding this in-browser validation, and I'll set rows to 5. That's another default attribute which we can add to text areas. Now last but not least, below that I'll add another div with a class name of classes actions, and in there I want to have the button that submits the form. So here we can add a button where we say add meetup, and that button will then submit that form. That's how HTML in the browser works. If you have a button in a form, a button which is not of type button, so if you have a regular button like this, then such a button will submit that form. And we can later listen to that submit event. And this should be actions as a class here. And with that, if you save that file, you should see this form on the screen. Now the form doesn't work yet, but it's there. Now to handle the form submission, we got to do two main things. We have to listen to the form submission, and we then actually have to prevent the browser default, which is that it sends a HTTP request automatically, and hence it would reload the page. We want to prevent this and instead handle the submission with JavaScript, with React. And in addition to that, we of course need to read the entered values. We need to get the actual input the user entered. Now let's start with the form submission. To listen for that submission, we can add the onSubmit prop on the form. Because by default, a submit event will be emitted if you have a button in a form and that button is clicked. And we can then catch this submit event here and run our own logic with help of that onSubmit prop. Now I will add another nested function in the new meetup form component function, let's say the submit handler, which should be triggered when the submit event occurs by connecting function and onSubmit like this. But as I mentioned a couple of seconds ago, the default behavior of the browser would actually be that it sends a request to the server serving this page automatically. And we don't want that. We don't want that browser default. Instead, we want to prevent that default and run our own JavaScript logic. That might then still involve that we send a HTTP request later, but we want to send that request behind the scenes without reloading the page, which is what would happen if the browser does its default thing. Now, thankfully, preventing that browser default is simple. We will get an event object automatically here. Because all those built-in events like onClick, onSubmit, and all the other events to which we can listen, for all those events, React will automatically pass an event argument into the function that is executed for those events. This argument, which we can accept here as a parameter. And this event object will have a prevent default method which we can call to prevent the browser default. That's actually not even React specific. This event object and this method, that is vanilla JavaScript, which is fully supported by React. So that will prevent that browser default and will allow us to fully handle the submission with just JavaScript and React. So that's step one. Now we need to find a way of reading those entered values. For reading the entered values, we got two main ways of handling this. We can use state again and add the onChange event listener to all those inputs, which will in the end trigger a function for every keystroke, and then we can extract that value the user entered from the event object which will receive for that event and update our state for that given input with the entered value. That would allow us to keep track of what the user entered with every keystroke. But here I'm actually only interested in the user input once, when the form is submitted. And for this we can use another concept built into React, the concept of refs. Now ref stands for reference, and React simply allows us to set up references to DOM elements, so we can get direct access to DOM elements. To set up such a reference, such a connection, we first of all have to import the useRef hook from React. So just like useState, that's another built-in special function offered by React, which we can execute in our functional components. And we can execute useRef here. And with that, we create a ref object, a reference object. We can store this in a constant, and we could name it title input ref, because my first ref here should be for this title input. Now, to connect this created object to this input, we add another special prop to this HTML element. Another special prop besides the key prop, which is built into React and supported on all elements out of the box. And that's the ref prop. We add the ref prop to this input, and as a value, we point at this title input ref. This will establish a connection and will give us access to this input element through this ref object. So here in this submit handler, we can then get the entered title, so the concrete value the user entered, by using that title input ref, and then there actually .current, all those ref objects created with the useRef work such that they have a current property, which then holds the actual connected value. And therefore it's .current, which then holds this input element object, the JavaScript representation of that input element. And all those input elements have a value property. That's just how JavaScript works. The JavaScript object representing an input element has a value property, and that value property holds the currently entered value of that input. So that's how we can extract what the user entered. We could also change it. We could set value to some new value, but we shouldn't really do that. If you want to change what's output on the screen, use state for that instead. But for reading input, for reading values, refs can be a very useful tool. And here we are reading what the user entered. Now we can repeat that for the other inputs, simply by creating more refs. You can have more than one ref per component. So here I also create the image input ref like this, and I'll already copy that a couple of times, and also create the address input ref and the description input ref. And then we connect those refs with the ref property here on the image. We connect this to image input ref. For the address, we connect this to address input ref. And on the text area, which is there to enter a description, we connect the description input ref. Now with that, we can extract all those entered values in the submit handler. So we get the entered image with image input ref .current.value. We got the entered address with the address input ref .current.value. And we got the entered description by using the description input ref current.value. And that then allows us to create a new object, let's say, the meetup data object, which then has a couple of keys, like let's say title, and stores those entered values as values. So the entered title for the title key. For the image key, I store the entered image. For the address key, let's say, we store the entered address. And for the description key, we store the entered description. And now for the moment, I'll simply log that meetup data with console log. Soon we will send it to a server instead. But for the moment, let's just see if that works. And hence, if I now go back and open up the DevTools here and reload, we can enter something here like test, and then here's some URL. Let me just grab that dummy image URL from my dummy meetup data in the all meetups.js file and insert that here without quotes. Some test address 12345 test city, and then this is a test. And if we now click add meetup, we see this object here on the right, which is the object with all the entered data. So submitting the form and handling the submission, preventing the browser default, and gathering all the user input all of that works now. And that is how we can handle forms with React. Now, of course, the goal is not to just log the data here, though. Instead, we now want to send it to a server, which then stores it in a database. So we want to send our meetup data to a server. This course is about React, about the front end. And therefore here, we will not write any server-side code or create our own backend. I do have separate tutorials on that. Got my Node.js course where you learn all about that backend technology, including how to connect to databases, how to create REST APIs, and much more. And I got a free tutorial as well where we also build a REST API in detail with Node.js step by step. Because with React, or with single-page applications in general, you typically need a backend API to which you can send your requests. So a backend which does not send back HTML, but which instead expects data in a certain format, typically JSON format, and which then returns data in that JSON format, and which simply exposes a couple of URLs to which you can send requests, and depending on which URL you're sending a request to, different things will happen. That's the kind of backend you typically connect to with React. Now, you don't connect a front-end application like React or Angular to a database itself. I got a full tutorial on that where I explain why we don't want to do that. You'll also find a link to that attached. You don't connect directly to a database with React and so on because of security. All the code you write here in your React application in the end is exposed to the visitors of your page. Through the DevTools, if I look at sources, if I dig into that, I can read the JavaScript code that makes up your application. It might look a bit different than when we wrote it, but all the code is in there. And database credentials would be in there as well. That's why instead we need a backend API, a backend server, to which we can send requests, and then it's that server which on the server connects to a database and stores data in a database. And hence that's what we're going to do here. Now, as I mentioned though, we're not going to write our own API, instead we're going to use Firebase as a dummy backend here. Firebase is a service offered by Google. It is actually made up of a bunch of different services, but it is a service which you can get started with for free. You just need a Google account. And it is a service which contains a database and an API to which we can send requests, which will then ensure that data is saved in that database. And for this, I'll therefore log in here with my Google account. And then once logged in, we can create a new project here. You can enter any project name you want here. I'll just name it React Getting-Started. Click Continue. You can disable Google Analytics, we don't need that, and create that project. Now, as I said, Firebase is a service which has a bunch of built-in capabilities. Here, we'll just use it in a very basic way to have this dummy backend to talk to. And I'm using this backend, this service, because that allows me to show you how you send requests to a backend, and you would then do that in the same way no matter which backend you use in the end. That's why that's a good service to use. Now here, we want to use the real-time database, which is one of the features Firebase offers, and then there click on Create Database. Now you can leave the default region and make sure that you start in test mode, not in locked mode. Otherwise, you'll not be able to send requests. Now this sets up a database and, very important, also immediately an API to which we can send requests. We can use this URL here to send requests to, and behind the scenes on Firebase servers, those requests will then be parsed, and depending on which kind of request we send, data attached to the request will be extracted and stored in the database automatically. And therefore it can look like if we're directly sending requests to a database, but we're actually sending requests to that Firebase API, which then behind the scenes stores them in a database. And therefore, that's the URL to which we now want to send a request when we submit that form. Now it's up to us where we want to send that request. If that's in the Meetup form component or maybe in the new Meetup page component. And since the new Meetup form component is already quite a big file, I will actually not add the HTTP code here, but instead in the new Meetup component code. So in the new Meetup form component, I just want to forward that Meetup data to the parent component, to the component where we use this component. And we learned that we can do that with props. We can accept props here in the new Meetup form. And then instead of console logging the Meetup data, we can expect that on props, we have some prop which actually gets a function as a value. A function which we can then call from inside here. Let's say the onAddMeetup prop. The name is up to you because that's our component. I expect that the value on this prop is a function, so we can execute it here, and I'll pass Meetup data as an argument. Now, of course, for this to work, we now need to make sure that in the new Meetup component, we now add this onAddMeetup prop, and that the value we pass in here is a function. So here I'll add a new function, the addMeetupHandler function, which expects to get some Meetup data, because I'm passing that argument here when I call the function from inside the new Meetup form component. So I expect that data here. And I then pass this addMeetupHandler function as a value to onAddMeetup. Like this, without parentheses, just pointing at it. Now in this function, that's where I want to send a HTTP request. Now for sending a HTTP request, we can use the fetch function. That's a default JavaScript function built into JavaScript. It has nothing to do with React. It's a standard JavaScript function supported in modern browsers. And it is a function that allows us to send HTTP requests. We could also use third-party packages like Axios, which is also a popular library for sending HTTP requests, but I don't want to install an extra library here, so I'll stick to fetch. Now fetch wants an argument, and the first argument should be a string. It should be the URL to which we want to send a request. And here that's that URL which we get from the Firebase real-time database console. Now this Firebase real-time database service works such that this URL can be manipulated. We can add segments after this domain, and then these segments will be translated into folders, you could say, in your database, into tables, you could say. So we could send a request to this URL /meetups, and that would add a meetups table, a meetups collection to that database here. And hence I'll do that here. Now, one special thing about this Firebase API is that you need to add .json at the end here. That's not React specific, that's just something Firebase requires. And with that, that is the URL to which we're sending our request. But here, I actually want to store data on Firebase servers. And to signal to Firebase and to this API that we want to store data, we actually must send a post request. And by default, fetch sends a get request. And that will always depend on the API you're working with, but most APIs are built such that storing data requires post requests. Now, to send a post instead of a get request, we add a second argument to fetch here, and that second argument is an object which allows us to configure this fetch function call and this HTTP request, therefore. And here in this object, we can, for example, set a method property to define the HTTP method that will be used. And here we can set this to post instead of get, which would be the default. So here we use post instead. Now, when we send a post request, we should also add the data to the request, the data which we want to store. And we do that through the body field, which we add to this second argument, to this configuration object. Now, body wants the data we want to append, and that data should typically be in JSON format, which is a very popular, the most popular, I would argue, data format for transmitting data with HTTP requests. And in JavaScript, we can easily create JSON by using the built-in JSON object and calling the stringify method. And to stringify, we can pass default JavaScript objects or arrays or values in general, and they will be converted to JSON. So here we could pass our meetup data object, which we're getting as a parameter, as an argument to the stringify method. Now, last but not least, we can add some extra headers if we want to. And for example, add the content type header and set it to application/JSON to add this extra metadata to the outgoing request and make it crystal clear that this request carries JSON data. Some APIs also require this. And with that, we're sending such a post request. We can do more with fetch. We can listen to the success and error cases, and we do that in the full React course, which I offer. But for the moment here, this is actually enough, because this will already send a post request with our data to Firebase. And hence now here, if we save this, and I click on Add Meetup Now with data entered, we don't see any feedback here. We'll work on that in a second. But if we go to Firebase, we see that there is a new Meetups node. And in that node, we got this cryptic ID here, which is actually auto-generated by Firebase. And if we expand this, we see our submitted data. So storing that data on Firebase servers works. Now let's work on the feedback which we provide to the user here when we add a meetup. To give the user some feedback that it worked, we probably want to navigate away from this page once the request was sent. And previously, we navigated through these links, which we added to the navigation here. Now we want to trigger navigation programmatically. So once we're done with a certain task, in this case, once we're done with sending a HTTP request. Thankfully, implementing this is also simple with React Router. We can simply import something from React Router DOM, and that something is another hook, the use history hook. So React has some built-in hooks. Other third-party packages also can provide their own hooks. You can also build your own hooks, but we're not going to do that here in this course. But here we now got this use history hook, and we can call this hook here in the new meetup page component function. Now this gives us a history object, and that's simply an object which exposes certain methods to us that allow us to manipulate the browser history, to navigate away, for example. Now here, let's say we want to navigate away after the data was submitted. To achieve this, we can use the fact that fetch returns a promise, which resolves as soon as this is done, and hence we can add a then block here and define a function which will execute when the promise completed, and it's then in this function where we want to execute history and then some method that allows us to navigate away. For example, the push method to push a new page onto the stack of pages. In that case, we could then later use the back button to go back to the previous page. And since that doesn't make too much sense after submitting a form, I'll instead use the replace method. That will navigate us away, but it won't allow us to use the back button to go back to the previous page. And here I'll just want to navigate to the starting page with /nothing. So in the end, we pass to replace what we also passed to link to the to prop. Here we set up the destination, the target destination of a link, with the replace and push methods on history, we also pass the target path as an argument now. Now, instead of then, we could also use async await here, by the way, if you wanted to. Now, with that, we're navigating away once the request succeeded, and therefore, let's now give this a try. Let's save this and enter some new data. I'll repeat using that image here, that dummy image URL, some other address, and some other description here. And then I'll click on Add Meetup, and you see that I'm now navigated away. And going back won't get me back to that forum. And on Firebase, we of course now also have that second meetup added here. And that's how we can navigate programmatically and leave that Add New Meetup page once we're done. Now let's make sure that the meetups we show on the All Meetups page are actually the meetups stored on Firebase, because at the moment that's not happening. So let's now make sure that we load the data we store here on Firebase into our application, into our website here, when we load this starting page. Because at the moment here in the All Meetups page, we're still using this dummy data, and that's of course not the goal. Now, to load data from our backend, from our API, we need to send a HTTP request again, just as we send one when we store data. So in the All Meetups JS file, in the All Meetups page component, we want to send a request. The question is, when do we want to send the request? And the answer is whenever this component is being rendered. So whenever we visit this page. So what you could do, what could be your first idea, is that directly in this component function, before we return the JSX code, we can fetch our data. We can use the same URL as we used for storing the data, since we want to fetch data from the same API and node. And hence we can use the same URL here. Now, we don't need to configure this request here with this second argument, because the default is that a GET request is sent, and that's exactly the kind of request we need here. We want to send a request to get our data. So we can call fetch just like this, and this will fetch this data. But now, unlike as with the post request, when we send data, now when we get data, we are definitely also interested in the response. Now, since fetch returns a promise, we can of course use the then method here and chain this after then to handle this response. So we pass an anonymous function to then, and here we'll get the response object as an argument automatically, because that's how the fetch function works. It returns a promise which resolves to the actual response at some point in time. Now, from that response, we want to read the body, we want to read the data, and we can do that with the JSON method. That's a method which exists on this response object out of the box, and this will give us access to that data automatically converted from JSON to a plain JavaScript object. But here's a gotcha. JSON will actually return a promise as well, so we also need to wait for this promise to resolve. So I actually will return response JSON here and add another then block where we then get the actual data. And it's now in this second then block where we can work on that data. We could also add error handling, and we do that in the complete guide course, but for the moment here, let's focus on just getting that data and using that data. So here in this then block, we get the data. What do we want to do with this data now? In the end, we want to extract an array of meetups from that response data and pass that as a value to the meetups prop on the meetup list. Now we'll have a problem here though. Since fetch returns a promise and we're in this promise chain, JavaScript does not wait for this promise to complete before we return here. Now you could think that we can use async await here to wait until this is done, but that would be bad because that would mean that the entire component function now returns a promise, because that's what the async keyword does. It converts this function to a function that returns a promise, and that then no longer qualifies as a valid React component, because React component functions must be synchronous and must not return a promise, but instead they have to directly return JSX. So we can't use async await here. Hence, we can't defer returning a value until we have a response. Instead, what we need to do is we need to return some temporary JSX code, for example, a loading spinner or something like this. And then once we have the response, we want to update the returned JSX code. And how do we change what's visible on the screen? With state. That's what we learned earlier already. We can use state to change what's displayed on the screen when certain conditions change. Before, we did that when the user clicked a button and we wanted to show an overlay. Now I want to change the state once we have response data. So for that here, in this all meetups.js file, we can import use state from React, so this use state hook, and then register some state here with use state. And here we could, for example, set up some loading state. So name the constant loading or is loading and add a set is loading state updating function, because you learned that use state always returns an array with exactly two elements, where the first element is the current state snapshot and the second element is a function for updating the state. And when we have data, we want to set is loading to false again because we're not loading anymore. But actually the initial state here should be true, not false. So we start in a loading state and then we set it to false once we have the data. And then with that, we could check if we are loading. Here in the component function, before we return, I check if we are loading. And if we are, then I want to return another piece of JSX code where I, for example, have a section with a paragraph where I say loading, something like this. So that's my fallback content, which I want to return in this component whilst we are loading. And we only return the actual meetup list if we're done loading, so if we have the data. But speaking of that, there we're missing an important point. At the moment we're just managing the loading state, we're not doing anything with the actual data that is being fetched. For this, we could add another state to this component. And that is something we haven't done before, but you can have multiple pieces of state in one and the same component, as many as you need. There is no restriction here. And this could be our array of meetups. And it could be an empty array initially, but eventually we want to override this once we fetched our data from the backend, from the API. So here I'll name this loaded meetups and set loaded meetups. And here we want to set loaded meetups to data, let's say. That will not be the final step, but for the moment we can do it like this. And then we could pass the loaded meetups instead of the dummy data to our meetups prop down there. And that means that now we can also get rid of that dummy data. So I will delete this dummy data constant. Now don't save this file yet though, because this code will cause an infinite loop. What's the problem here? The problem is related to state and our HTTP request. You might recall that I mentioned when I introduced state that when we call this state updating function, we tell React that it should re-execute this component function and re-evaluate it, and then return the updated JSX code. That's the idea of state. It allows us to re-evaluate a component and possibly render different content on the screen whenever state changes. The problem here is that we change state once we made our request. We change the loading and the loaded meetup state. Then this component function will execute again. What does this mean? It means that this fetch function will run again, and we send another request. And once that's done, we update the state again, which means the component function executes again and fetch is called again, and so on and so on. So we have an infinite loop, and that breaks our application and spams our API with requests, and it's not something we want. How can we prevent this? So how can we work around that problem? This is such a common problem and such a common scenario that React has a solution for it. There is another hook which we can import from React, and that's the useEffect hook. useEffect is a hook that allows you to run some code under certain conditions. At the moment, this code for sending the request runs always when the component function runs. With useEffect, we'll be able to restrict this and define conditions when this code should run, so that it does not always run. For this, we call useEffect. We execute this useEffect function directly in our component function, and then useEffect wants two arguments. The first argument is a function, and here I will pass in an anonymous arrow function. The second argument is an array of dependencies, and I'll come back to this array in a second. Now, inside of this first argument, inside of this function, we can execute our fetch code here. So I'll cut this and add this into this effect function. Now, this effect function, this first argument here, which we pass to useEffect, will be executed by React on our behalf, but only under certain circumstances, not always when this component reruns. I'll come back to those circumstances in a second. Now, with that, we make sure that our fetch request here, our fetch function, is only executed when React executes this function. Now, when does React execute this function though? If we would not specify this second argument, this array, if we would omit this, then this effect function would execute whenever this component function executes. So then we don't gain anything. That's why you need this second argument. You technically don't need it, it's not required, but if you omit it, there is no difference compared to just running the code in the component function. With this second argument added though, React will check the values you add to this array and compare them to their equivalents when this effect function was executed the last time. Now, if that's an empty array, there are no dependencies. And then React will only execute this function when this component function rendered and executed for the first time. And for subsequent executions of this component function, this effect function will not run because we have no dependencies. So the values of the dependencies are always the same because there are no values. Now, if you would add a dependency here, like let's say the isLoading state snapshot, which you should not, but if we would have this as a dependency here, then this function would execute whenever the value of isLoading changed. So if that value does not change, if that always stays the same, then this would also not execute again. But if isLoading was false, and then you somewhere update its state to true, then the value of isLoading would have changed, and then this effect function would execute again. Now, in reality, you don't need to think which values should trigger your effect function. Instead, there is a simple rule. In your dependencies array, you should add all external values your effect function relies on. So in this case, there are no external values. The fetch function is a built-in browser function. It's not one of our component props or state. And other than that, we don't use any state or prop values in this effect function that would belong to our component. If we would extract some data from props here though, if we would, for example, get the URL from props URL, let's say, then props would be a dependency and we should add props here. But that's not the case here, but that is how it would work then. Set is loading and set loaded meetups actually technically would be external dependencies because these are constants defined outside of this effect function, but these state updating functions are an exception. You can add them here, and that would not be incorrect that these functions are external dependencies, and whenever these functions change, this effect should run again, because then these functions might do different things than they did the last time they were executed. But React actually guarantees that these state updating functions will never change. They will always do exactly the same thing. And therefore it's allowed to omit these functions here. And hence, in our scenario here, we use useEffect like this, with an empty dependencies array, since we have no external dependencies here, and therefore this code will only run once when this component is rendered for the first time. Now I dive way deeper into useEffect with more examples and also more features of this hook in my course, but what you learned here is the core foundation of useEffect, which you have to understand. That you can use it for running such side effects, as they are called, code which does not directly influence what's showing up on the screen, and that for such side effects, useEffect is the proper solution for controlling when this code should run. Now with that, we actually should also set isLoading to true here at the beginning of this effect function, so that whenever this effect would run again, we set this to true again. It doesn't run again here, but still, that is cleaner, I would argue. And then we send this request, and ultimately, we update our loading state again, and we set our loaded meetups to the data we fetched here. And now with that, it still won't work, because setting the data like this is incorrect, as it turns out, but we don't have an infinite loop. And I hope I could make it clear why that's the case. If we now save everything, our app crashes, because as I said, we're setting the wrong data, but we don't have an infinite loop. So now what's wrong with that data though? The problem with our data is that when we fetch meetups from Firebase, we actually don't get an array. Instead, we get an object where these cryptic auto-generated IDs act as properties. So when we send a GET request to our Firebase API, we get back an object with two properties in this case, and these here are our property names, and then nested inside of these properties, we got nested objects with the actual meetup data. Now, here in our component though, we expect an array, because in meetup list, we map on our data, and that only exists on an array, not on our object. Hence, we need to transform the data here in all meetups before we set our state. Once we fetched the data, so in this second then block here, we want to transform the data. And we can do this for creating a helper array here, meetups like this, and then a for in loop where we go through all our keys in data, so all the keys in this data object we fetched from Firebase, and these keys will be these random IDs here, these unique IDs, that will be our keys. And then we create a new meetup here for every key through which we loop. So for every meetup that's stored on Firebase. And we can set the ID equal to key, since that is that auto-generated ID. And then just distribute data key into this object. So we access the nested object for the given key. So we access the nested object here. And then we just use the spread operator, which is a default JavaScript operator, to copy all the key value pairs of this nested object into this object. And that constructs a meetup object as we need it. And then we just need to push that onto our helper array here. And then it's this helper meetups array, which we want to set as our loaded meetups data. And now if we do that, if we transform the data like this, if we save this and reload, we see loading briefly, but then we see all our meetups. And that's how we can fetch data, in this case from Firebase, but in general with useEffect, fetching data with a loading and a data state without causing an infinite loop. Now that we can add data to Firebase so that we can store data on a server and that we can fetch data whenever we visit all meetups, now with that we got the core functionality built in. The last feature which I want to add here is this favorites feature. This button here should be clickable, and when we click it, this meetup should be added to our favorites. Then on the My Favorites page, I want to see a list of all my favorites. And of course, as soon as an item is a favorite, I want to be able to unfavorite it. And then I also want to show a little badge here in the navigation next to My Favorites, where we see the current count of favorites. That's the last feature I want to add. And for this, we'll need to manage some state which affects more than one component. Because our list of favorites is some state that should cause the UI to update. Because we, for example, will have that badge here, which shows the current number of favorites. And of course, this button should change once an item is a favorite. So we'll have different parts of this application that will be affected by our state. And because that's the case, because we'll have a state that affects more than one component, we will need a mechanism of managing that state globally and distributing that state to different components. Because just using useState inside of a single component doesn't necessarily do the trick anymore, because that only affects one component. Now, one thing we could do is we could lift the state up. That means that we could, for example, manage our favorites state in app.js, and then we pass it into all the components that are interested as props. So to the layout component, which has access to the main navigation component, which is where I want to show this badge in the end, to that component, we could pass the number of favorites if we manage the favorites state in the app component. And then to the favorites page component, we could pass the array of favorite meetups. So we could manage the state here in the app component and then just distribute it through props. That would work, but it has a couple of downsides. One problem would be that if we have a bigger application with different states that affect different components, we have to manage more and more state in this app component. And hence this app component becomes bigger and bigger. And that's maybe not ideal. Another problem is that if we pass state down through props, that we can end up with very long prop chains. We pass the number of favorites to the layout component, and from there we pass it into main navigation. So we already pass props to layout just so that this component can then pass that data on to another component. Whilst that is not horrible, it's also not necessarily great, and it can also make our code a bit harder to maintain. And because we have issues like this, there are state management solutions for managing application-wide state in a more convenient way. One very popular state management package is Redux. I cover it in my course, but for many scenarios, we don't even need Redux, because React also has a built-in state management solution for application-wide state. And that's a feature called context. Now for this, to add this context feature, I'll add a new folder in the source folder and I'll name it store. The folder name is up to you, but store is a common convention since we will set up the state store for this application. Inside of store, I'll add a favorites-context.js file. And in this file, I'll now create such a context. For this, in this file, we first of all import create context from React. So that's a function exposed by the React library. And we can then call create context. And this does what the name implies. It creates a context. We don't know yet what exactly such a context is, but hey, we are creating one at least. Now, context in the end is a JavaScript object. And we can store this in a constant, and I'll name it favorites context. I start with a capital F because this object, which is created by context, actually will contain a React component. And when you build your own React components, the convention which you should follow is that you start with a capital character for your component names. So that's why I store my context in a favorites context constant here. Now, create context also takes an argument, and that argument is the initial value for that context. So the initial value for this application or component-wide state. And that can be any value of your choice. It could, for example, be an object. Let's say an object where we have a favorites key, which is an empty array initially, because we have no favorites at the beginning. And maybe a total favorites key, which is 0 initially, which is the total number of favorites. That could be our context. But like this, it's not too useful. We also need ways of changing these values, of adding and removing favorites. And that's why I will also add a component in this file. So a component function, which I'll name favorites context provider. This component will be a regular React component, but it will have the job of providing this context to all the components that are interested in listening to the values. So all the components that need values from the context. And this component here, the favorites context provider component, will also be responsible for updating the context values. Now for this, what we'll do here is we'll return favorites context, so this constant which we created here, dot provider. That's a component this context object has built in. And this provider component needs to be wrapped around all the components that are interested in interacting with that context. Now, this favorites context provider component, which we are building here, itself should be wrapped around other components later. I plan on using it in index.js to wrap it around my entire app so that all the components in the app have access to the context. And therefore, what we can do here is we can accept props and simply wrap this provider component, which we get from this context object, around props children. That means that we can now wrap our component here around any other components, and those components will be wrapped by context automatically. I hope this makes sense. Now, why am I doing it like this? Because now in this favorites context provider component, which we're building here, we can manage our context data. We can manage that with state, because this component, which we are working on here, is still a regular React component. So when we manage state in there, when we change that state, that component here will still execute again and will be re-evaluated. And that means that if we change our context value in this component and we pass this context value to the provider, all components that are listening to our context will be updated and will get that latest updated data. And in case it's not 100% clear yet, we'll get there step by step because we're now going to add the logic for this. In favorites context provider, I'll create a context object, and I'll pass this context object as a value to favorites_context.provider. This component, which is exposed by this favorites_context object, wants a value prop where we pass the current context value. We set the initial values here when we create the context, but we can then update those values and pass the latest values with help of that value prop. And whenever that value changes, all components that are listening to our context will be updated in the end. That's how this works. So now we just need to derive this context object and its values dynamically. And that's where useState comes into play now. We can manage some state here in this favorites context provider, and we can manage an array of favorited meetups here. So here we have the user favorites, let's say, and a function for setting those user favorites. Now here, this context object, which we construct, which holds the latest values that should be exposed to our components, that object now has a favorites key because we define that here in the initial context value as well. And we set our current user favorites array, this state snapshot, as a value. So when the state changes, this value will change and we'll have a new context object, and we'll pass this new updated context object to all the components that are wrapped by this provider in the end. And I'll also set total favorites here, and that is simply user favorites.length. Like this. Now we just need a way of changing our state here. And of course we can do this with functions. We can add a function that's called the addFavorite handler, for example, and a function that we could call removeFavorite handler. And I will also add a helper function, which I'll name itemIsFavorite handler. That's a function which will later help us determine whether a given item is a favorite or not. Now in the addFavorite handler item, I expect to get my favorite meetup as a parameter. And then in there, I want to set my user favorites to the old array plus this new item. Now for this, we could use user favorites.concat and add the favorite meetup. Concat is like push, but returns a new array, and it's then this new array with that added meetup, which we set as our new state. But there is a gotcha. We should not do it like this, even though it typically will work. When working with useState, it is worth knowing that React actually does not process state updates instantly, but it schedules them behind the scenes. And it still then processes them very quickly, but not instantly necessarily. Now, because of that, when you update your state, and your state update depends on the latest state snapshot, there is a scenario where the state snapshot does not really reflect the latest state because the last state update wasn't processed yet. And because that is the case, there is an alternative form of calling this state updating function if you depend on that last state snapshot. Instead of passing the new value as I did it a second ago, you should pass a function to the state updating function. And that function will be executed for you by React. That function will then automatically receive the previous state snapshot, so the previous user favorites here, and you should return the updated state here. So in this case, previous user favorites, where we then concat the favorite meetup we get as a parameter. This will guarantee that we always get the latest state snapshot here, because React will execute these functions, which we pass to the state updating functions, in the correct order. So now we have a guarantee that we definitely work on the latest state snapshot here. And that's therefore the better way of updating your state if you depend on a previous version of that state. And that's now how we could add a favorite item. Now in remove favorite handler, we probably can expect a meetup ID which identifies the meetup that should be removed. And then we can update user favorites again with this state updating function where we get the previous user favorites and return a new state snapshot, because here again we rely on that previous state. And here we then want to return previous user favorites, filter, because filter returns a new array where we can filter out items. And I want to filter out the item where the meetup ID matches this ID we're getting as a parameter. Filter is a built-in method which takes a function as an argument, which executes for every item in this array, and we get that item as a parameter then. And then we have to return true if we want to keep that item, or false if we want to get rid of it in that new array which is returned. And here I want to return true if meetup ID is not equal to the meetup ID I get as a parameter. So if it is equal, we return false here because of this check. And that means we drop the item where the ID is equal. And that means that the returned array will be missing the item which has this meetup ID, which is exactly what we need here since we want to remove that item. And in item is favorite handler, I just want to return a response here, return a value, and I want to check whether, let's say, an item with a given ID is part of our favorites. And for this, we don't need to update any state. It's just a helper function where I return user favorites sum, which is another built-in method which exists in vanilla JavaScript. And sum also wants a function as an argument, which executes for every item in this array. And this function should return true or false. And if at least one of the items in the array returns true or false with that function, sum overall will return true or false. And that allows us to find out if some item in this array matches our condition here. And the condition is that some meetup ID is equal to the meetup ID we get as a parameter. So we return true if we have a meetup with that ID in our user favorites. Now we get these three functions for changing our context. But at the moment, these functions are never called anywhere. They should instead be called from inside some of our other components and pages. So actually what we want to do here is we don't just want to manage values which are then accessible by different components, but also functions that will change those values that are accessible from different components. And hence we can expose pointers at these functions to our different components as well. So in our context here, we don't just have the values for our favorites, but we also can add functions there. We can add an add favorite key, for example, which stores a pointer at the add favorite handler as a value. So we don't execute the function here, we point at it. And that exposes this function defined in this component to all components in this application that are interested. And you will see how to use this context in other components in just a second. And we can therefore also add remove favorite here and point at the remove favorite handler, and add the item is favorite key and point at the item is favorite handler function. And now we expose these functions to all interested components as well. Now that that's the case, I will also go to my initial context and add those keys here as well and set that to empty functions that just get the correct parameters. And I'm only doing this because that will actually give us better autocompletion later. It doesn't really do anything here since these are functions that don't do anything, but it will help us with autocompletion in the IDE later. And that's why I will just add them here to the initial context as well. Okay, so now with that, we spent a lot of time in that file, and I could imagine that it's not all 100% clear yet, but we're now done with working in this file. Now we need to wrap our context provider around all components that want to interact with this context. And then in the different components, we need to pull out the values we're interested in or call the methods, the functions here we defined. And for that, we need to export this favorites context provider component here by adding the export keyword in front of this function. And also, maybe at the bottom of the file, export the context as itself, the favorites context itself, as a default. So we have two exports, this function here, which we export by its name, and then this default export, which is our favorites context itself. These two things are exported here because we need to interact with both objects, with both things from outside this file. Now let's start with interacting with this favorites context provider component. I mentioned multiple times that we want to wrap this component around all the components that are interested in our context data. And in this case, the My Favorites page will be interested, the navigation bar will be interested since I want to show a badge here, and the All Meetups page will also be interested, or to be precise, the meetup item components will be interested because there I have this To Favorites button, which, for example, should trigger the Add Favorite handler. So I have various components from all over the app that are interested, and hence the easiest way of providing the context is probably to wrap everything with it. So here in index.js, I will import the favorites context provider from the store folder, and there the favorites context file. And actually, I'll wrap it in curly braces because I don't want the default export, the context object here, but I want my component function instead. This favorites context provider function, which I export like this under its name. And we import named exports between curly braces. That is standard JavaScript. Now we can wrap this provider component around the browser router and the app. And with that, everything, all components in this application are able to interact with this context. Now, how do we interact though? Let's maybe start with the meetup item component. Here we have this To Favorites button. I want to make sure that when this button is clicked, we add this item to our context. And I also want to update the text on the button depending on whether this item is already part of my context or not. And actually, if it is part of the context already, if we already did favorite a meetup item, this button should no longer add this item to the context, but remove it from my favorites array in the context. Hence, first step is to add a function in this meetup item component, which we could name toggle favorite status handler. The name is up to you though, and I'll bind this function to the onClick prop of this button, so that when we click this button, this function will be executed. And now in this function, we will need data from the context. We need to find out whether this meetup item is already part of the context or not, and then do different things depending on that information. Now for that, we now need to tap into the context and get values from there. And we do this with help of another hook provided by React. And that would be the use context hook. This hook allows us to establish a connection between this component and the context, simply by calling use context here and then by passing the context object to which we want to connect as our argument. And here I'm not talking about our favorites context provider component, but about the context object which we created with createContext. which is why I'm exporting that as a default as well. With this in meetup item, we can import the favorites context, like this. So that default export from going up, store favorites context. And it's then the favorites context which we pass to use context. And that now gives us access to this favorites context object. So to this object here, which we're distributing through the value prop to all the components. So to this object will have access now inside of meetup item. That's the object which is stored in this favorites CTX constant now. And now we can, for example, find out if this item, this meetup item here, is a favorite by using this favorites CTX constant and calling item is favorite. So this method, which we defined on our context there as well. This method which points at the item is favorite handler function. We execute this function now by executing it here in the component like this. And we need to pass in the ID of the meetup for which we want to check whether it's favorite or not. And we get the ID of this meetup through props. There is this ID prop which we pass into our meetup item here when we render it. So we can use props.id to pass the ID of this specific meetup to item is favorite. And that will return true or false. So here we then have that response. Now here in the toggle favorite status handler, we can check if the item is a favorite. So if this constant has a true value. And if that's the case, we know that we want to remove that item from the context now when that button was clicked, because it is a favorite already, which means now we want to get rid of it. So then we use our favorites CTX constant, this context object, and call remove favorite. And remove favorite also wants the meetup ID, so we pass props.id here. Else, if the item is not a favorite yet, we call favorites ctx.add favorite. And here we need to pass in a new meetup item now, so I will construct an object on the fly and simply set my ID to props.id, the title to props.title, the description to props.description, the image to props.image, and the address to props.address. And that now recreates this meetup item and passes it as an argument to the add favorite function, which in the end triggers this add favorite handler function in this favorites context provider component. And that will then update the state there, add this item to the user favorites array. And because the state was updated, it will update all child components, because this component here as a whole will be updated, and hence the JSX code with all the child components will be updated again, and hence all components will have access to that latest state now. So that's how we can now trigger a state update to this global state, this favorite state, from inside the meetup item component. We change some state which is not managed in this component, but on a global level. And now going down to this button, we probably want to change the caption, depending on whether the item is a favorite or not. So I'll output something dynamic here as a caption and check if item is favorite. So I'm using this constant here again, which has true or false as a value. And if it's true, then the button should say remove from favorites. If it's false, so if the item is not a favorite yet, the button should say to favorites, because then clicking the button will add the item to the favorites. And now that was a lot of work. But if you did all of that, if you saved this, now you should be able to reload and click to favorites, and it should change to remove from favorites, and back and forth. We don't see the favorites on the My Favorites page yet, but adding favorites does work, as we can tell by this button. Now let's make sure we also render the favorites on this My Favorites page and that we have a little badge here. So to output the favorites on the My Favorites page, we can go to this Favorites page here in the Pages folder and again tap into our context here. Because on this page, we now in the end want to get all the favorites from the context. Now for this, we can of course import use context again from React and also import the favorites context object from the store folder and their favorites context. And then we connect to the context just as we did it before. We create a constant, which then stores this context object, and we call use context and pass this context object we created in that context file to use context. And that gives us the current context snapshot then. Now we got our context here, and that means that now from that favorites context, we can get our favorites array. So in the end here, we can now return, let's say, a section where we say in a h1 tag, my favorites, and below that I want to output a list of meetups, a list of my favorite meetups. For this, we can recycle the meetup list component because this component does not care whether it's all meetups or a subset of the meetups. All it cares about is that we output items that have these properties. So we can import meetup list from the components folder, meetups, meetup list, and then output that below the h1 tag, meetup list like this. And set the meetups prop here equal to favorites ctx dot favorites, because that is our array of favorites. Now if we do that, on that favorites page, we see all the favorites we have. The problem just is that if I remove a favorite, we don't see anything here, which makes sense because I currently have no favorites. But we might want to render some fallback message for this case. And one way of doing this is that we define a little helper variable here, content, and we then check if favorites context total favorites is equal to 0. Total favorites is another property we're managing in our context. And if that is 0, we know we have no favorites. Then I'll set content equal to, let's say, a paragraph where I simply say you got no favorites yet. Start adding some, question mark. Else, if we do have favorites, I set content equal to my meetup list here. So in the end, to this line of code. And this might look strange, storing HTML elements in variables, but it's actually not stranger than returning HTML elements. You can use JSX code anywhere where a value is needed. We saw it in arrays, in return statements. You can also store JSX in variables. That is totally fine. And now we can simply output the value of that content variable in our returned JSX code to then have different values here, depending on whether we have favorites or not. If we now save this, I got no favorites yet here, but if I add an item as a favorite, I see that instead. And if I remove it, we're back to this other text. So this works. One important note though, if I add an item to my favorites and I then reload the page, it will be lost. The reason for this is that our context is only stored in memory because we're only working with state and with constants here. It's not stored permanently. If you would want to store it permanently, you would need to use some browser storage here in the favorites context provider, like local storage, for example, or store it on a server as well. I'm not doing that here because I want to focus on this core feature of React context, but that is something you could add if you want to enhance this application. For the moment, it's simply some temporary storage which survives as long as we are on this page. But if we ever reload or leave the page, our favorites will be lost. Our meetups won't, because those are stored on a server. It's just something that is worth knowing. And now with that, that's almost it. As a last step, I now just want to make sure that in the main navigation, we also see a badge next to the My Favorites text that indicates how many favorites we currently have. And that simply means that in the main navigation.js file, we also want to connect to context and get values from there. So I'll again import use context here from React and import my context object, the favorites context from going up, store favorites context. And in main navigation, we then get the favorites context by using use context and connecting that to the favorites context. And then here on the favorites link, we can simply add a little extra span next to this My Favorites text, in which we output favorites ctx.total favorites, because that is a number managed in our context with the total number of meetup items in our array. And I'll give this span a class of classes.badge, which is one of the classes prepared in this CSS file I gave to you earlier. And with this, we now have this badge here. And if we add items to the context, that badge does update. And also if we remove items, of course. Now that's it for this summary of React. We had a look at all the core features that make up React, like state and use effect and context and components and props, of course. And we built this little demo earlier, and now this demo project here, which uses more features, including features like routing and forms. Of course, React has more to offer, and you can also dive deeper into the concepts I touched on here. For example, use effect has more to offer than what we're using here. But that is why I do have a complete course with more than 30 hours on this topic. However, this summary here gives you all the core features and a good foundation which you need to dig deeper into React, and therefore hopefully it's now a bit clearer what React is, how it works, and you now should be able to get started building your own React projects as well.